There's a company in Montana.
All right. Good afternoon, everyone. Welcome to this afternoon's roundtable. This session is part of New York State and NYSERDA's development of a roadmap to carbon neutral buildings for New York. My name is Zach Zill. I am part of NYSERDA's new construction team. I'm speaking to you from New York City, where a bunch of folks are gathered at the Department of Public Service. We are also joined by a group of attendees in NYSERDA's Albany offices, and many of you are also joining us remotely via webinar or conference line. Thank you for being here. This afternoon's session is going to be a roundtable discussion on the grid side of building electrification, and specifically we will be discussing the technical considerations for large-scale building electrification. Let's go to the next slide, please. I'm going to kick us off with just a few introductory and housekeeping remarks before I turn it over to my colleague Patrick O'Shea. So for those of us who are joining remotely, please make sure to mute yourself when you are not speaking. That may be muting your phone or muting your computer or both of them. That greatly facilitates a seamless and audible discussion for all of us. And for all participants, we're not going to do a round of introductions at the beginning of today's discussion, so we just ask that if you are speaking during the discussion, please introduce yourself prior to making your remarks. Name and organization is fine. We're asking that everyone participating in today's discussion be cognizant of the various voices and perspectives that are contributing to this discussion, including people who may not be in the room with us today. We also ask that everyone has a little bit of patience with the process because we are doing this in two different physical locations and remotely. There sometimes are some IT hiccups or background noises that we have to deal with, and we thank you in advance for working with us as we work through those. And then lastly, I just want to say that to facilitate as full a discussion as possible, if a previous speaker has made comments that largely mirror those of your own comments, just say ditto rather than restating the whole comment. Okay, next one. All right, so for those of us joining via webinar, the next couple slides just show you how to type in comments or questions using the WebEx function. There are a Q&A and a chat bubble icon at the bottom of your screen. If you click on either of those, it will bring up a text box, and you can type a comment or a question in there. You do not have to type in your comments or questions. We can also call on people to contribute in real time. But if you prefer to contribute that way, that is an option for you. You can also send messages here to our team that's running the meeting. If you are having trouble hearing or having other IT difficulties, please send us a note about those. Okay, so the agenda for this afternoon, we're going to have a quick introduction and overview of the road mapping process, and then we will dive right into two discussions. The first one will be kicked off by what we're calling a lightning round of presentations. Those will be given by a group of various experts, subject matter experts on this topic, and that will tee us up for our first discussion on the technical considerations to enabling large-scale electrification of buildings. We'll have a short break just before 3 p.m., and then we will go into our second discussion on future-proofing. What near-term investments are needed to support building electrification and building grid integration? So those are the two discussions that we're planning to have this afternoon. Again, thank you to everyone for being here, and I think that is my last slide. And with that, I will turn it over to Patrick O'Shea, who is in NYSERDA's Albany offices. Patrick is the Director of Market Development at NYSERDA. Take it away, Patrick.
So, Zach, can you hear me?
Yes.
Okay. So you want to go to the next slide? So the carbon neutral buildings roadmap. So we've had a core team that's been working now for about a half a year on the roadmap, and this is one of our many subject matter expert stakeholder input sessions. Primary focus of today is getting your input. We're going to focus in this session on the the promise of new and flexible technology to in terms of the grid that can help provide more options and a better value proposition to building owners who adopt clean energy attributes. So when you look at the, our scope of work is really the building decarbonization roadmap. But when you look at the building decarbonization roadmap, you understand that there's how buildings present themselves to the grid, and there's how the grid presents itself to buildings, and that both of those need to be anticipated to drive the decarbonization of the buildings to the maximum level that's possible. And one of the things that we're very, very interested in is making good assumptions. Obviously, some of this is off in the future in terms of when the capabilities will actually exist. The other thing is building out the fullest value proposition possible, decarbonizing the existing buildings. So we are, in scope, we're taking on both new and existing buildings. Decarbonizing existing buildings, we really need the fullest possible value proposition so that companies who do this work can do so profitably, investors who make these investments can get a return on their investment, and we can get as much scale as quickly as possible. So you want to go to the next slide? So we are doing the roadmap in conjunction, and our primary audience for the roadmap will be the Clean Energy Council that's coming out of the New York State Clean Energy Community and Protection Act. This is part of the overall goal of a carbon-free economy by 2050 in New York State. And we are obviously cleaning the grid at a more aggressive pace, the wholesale electric grid. Obviously, something that's being worked on right now is New York State's natural gas policy. And in conjunction with our roadmap for the broad building decarbonization, there also in the same time frame is an electrification roadmap being worked on in conjunction with NYSERDA and DPS. So you want to go on to the next slide, Zach? In addition, many of you are based in New York City, and you're already being impacted by the New York City Climate Mobilization Act. It is one of the most aggressive sets of targets in the country, and there are some penalties and options that are beginning to impact how investments are being made in the city. We are working on a state roadmap. We're hoping to provide consistency and guidance that will be useful to the city going forward, and we expect we'll to be engaged with the city in terms of what we're looking at as we go forward into the future. Next slide. So in building a carbon neutral roadmap, and I'm not going to read every aspect of the slide. We do want to, in addition to kind of the policy side, and having policy drive decarbonization of buildings, we also are very concerned about building demand for these buildings to create a broad understanding of the benefits of living and working in these buildings. So it's not just the energy savings, but the health, the comfort, the productivity, and the resilience of these buildings. So and the other thing that I would mention at the bottom, it says it's a living document. So we're working on, iteration one of the roadmap. Iteration one of the roadmap, we expect to have done about a year from right now, January of next year, so it can feed into the CLCPA process. But we expect the roadmap to be updated on a cycle that's similar to the state energy plan. In terms of what we look at in the living document is we're focused on things that can be done now or started now that really can live within the 5 to 10 year time frame. But then we're also looking at the broad arc of things that may not be possible to do for 10, 20, or 20 years. And the scope of our roadmap is the arc to 2050, so it's got a 30-year arc. You want to go to the next slide, please? Some of the things, so it is, as I mentioned earlier, it's new construction and existing buildings. On the new construction side, in addition to the looking technically at the buildings, we're also looking at capturing code and have code move forward. We're expecting that in the residential, multifamily, and commercial office, low and mid-rise space, that we'll have built carbon neutral into the code by 2030. That's 3 code iterations from now, if you work in the code world. That's the kind of thing we're targeting for. We think that it's both economical and technologically achievable. The existing buildings present a greater challenge. We're looking at both comprehensive, or what's called, like a deep clean energy retrofit, and phased improvements of building over time. So we expect that much of this work will not have an economic return unless it's done at a time that the building would go through a normal capital upgrade or retrofit that's required anyway for other reasons. In the initial iteration of the roadmap, we're going to focus on single family, multifamily, commercial office, and higher education. And the buildings that we're going to focus on in higher education are classrooms and dormitories. This gives us a big block of relatively straightforward buildings, where we believe that we can create a pathway. For the moment, we're not going to be taking on specialty buildings where high loads of process energy define their energy use, as opposed to the building envelope itself. We're not going to be taking on skyscrapers in the first iteration in terms of pathway. And when I say this, I'm talking in terms of a pathway. We will be doing research in those areas, but we believe there's a pathway in these other areas. So anyway, a straightforward pathway is what we're going to be looking for. And in the areas where we don't have a clear pathway, we'll start research, but we will be working on those sectors as we update the roadmap. The next slide, please. So there are various components of the roadmap. I'm not going to read them off, but there are a lot of things that we have to look at in terms of a building roadmap. And then you want to go to I believe, the final slide for me. So time frame. And this time frame is close to the right time frame. So we expect to, as the year ends, to be wrapping up, although we'll probably have a couple of small sessions in January, to wrap up our subject matter expert input. We have research going on, and early next year, we'll be getting the outputs of our initial round of research. We'll then shift into writing mode and editing, and we expect to produce for the market a first draft of the comprehensive roadmap approximately April 2nd. I'm not going to say April 1st, April 2nd. Anyway, and at that point, we'll move into a public stakeholder process and hold open sessions where stakeholders can comment on the entirety of the roadmap. So right now, it's subject matter expert input that we're seeking, research input that we're seeking, and input on the roadmap itself will begin early in the second quarter of this year. We'll go through a multi-month process of stakeholder input and comment, and then we'll be looking to produce a final draft coming out of at the end of the summer, early fall. And then, as I had mentioned, we're looking to publish now, I believe, in January of 2021. And we're looking to publish at the same time that the electrification roadmap is published. And the electrification roadmap will nest in this, it'll have its own life because it's going to have funding from DPS to drive building electrification. But in terms of the role of electrification in decarbonizing the building stock, it'll be nested in this broad roadmap.
Patrick.
Thank you. Yeah.
Aaron Breidenbaugh with Consumer Power Advocates. We represent primarily hospitals and universities down in the city. You mentioned higher education, but I didn't catch what was the focus that you were going to, limitations on the focus? Or?
So the building focus, we're looking at, so I'll talk about a research topic and then the building focus, but thank you for bringing that up. So the building focus is how we move dorms and classrooms towards net zero. And then a research focus that we're specifically going to have is a lot of campuses have steam system central plants. And we actually have a separate stakeholder session coming up on that topic. Will that be in December or early January? Early January. And anyone that would like to participate in that, we would be very interested because we know that these large campuses, that's going to be one of the biggest challenges as we decarbonize the built space. What we're not taking on is more specialized buildings that have that are defined by high process energy use at this point in time.
What about hospitals?
Hospitals, well, we were asked, so to the degree, so when we look at the categories that we picked overall, so if I take office and multifamily and the higher ed, we're going to find that a lot of our solutions in those spaces can be applied in other environments, but we were asked to narrow. In fact, we had a fight to get a fourth category in the initial roadmap. There's just so much work to be done that. And the goal of these four categories is to provide a pathway. So in this first round, point out a technical and economical pathway to getting to decarbonize. So it's just beyond how many things we could work on in the first round. And at this point, I'd like to, and thank you for your question. At this point, I'd like to introduce our facilitator, Scott Johnstone. Scott Johnstone, many of you may have run into Scott when he was the executive director of the Vermont Energy Investment Corporation. Scott has lots of experience in New England and Vermont with this overlap of the building space and the utilities and the grid. And I will let Scott take it from here. Thank you.
Great, thanks, Patrick, and welcome everybody. And one thing I'll tell you is you have a choice, right? You're either gonna come into this after lunch with lots of enthusiasm and lots of energy, or I'm gonna make you all do exercise. So it's really totally up to you. But I do know that right after you eat, and for many of you after a long morning in this room and paying attention in the rooms you're in, our energy can ebb. But we're doing really important work here for the state of New York and the city of New York. So let's find our energy and be ready to drive forward. For the folks here in New York City, there are a lot of chairs up here at the table. You're welcome to join. It's easier to grab a microphone that way. And if you're uncomfortable with that, we have a podium set up, and we ask that, when you get to a point when we get to the discussion phase, just walk up there and I'll get to you. We've got about 20 here in New York, about 35 online, and it looks like on the screen, half dozen or so folks in Albany. So we've got a great crowd to jump into this. And if you go to the next slide, the first thing I want to do is just make sure that we all have a good sense of the definition, a couple definitions we're using. They're both from the Department of Energy. And the first is on this notion of grid interactive efficient buildings. This one comes from the building technology, and it's an energy efficient building with smart technologies characterized by active use of demand energy resources to optimize energy use for grid services, occupant needs and preferences, and cost reductions in continuous and integrated way. And then grid modernization is really looking at that it has to improve reliability for everyday operations, enhance security, and add additional affordability to maintain our economic prosperity and provide superior flexibility for the varied and still uncertain energy sources of the future, right? So it's got to be adaptable. And so those are just a couple definitions we're using. We're not making them up. We're creating things from whole cloth. But as we walk into this conversation, it's worth just starting with some common understanding of the terms that we're using. Those are the only two that really came up. And so with that, the first thing we're going to do here is have a series of lightning round presentations. We've got 5 presentations teed up, and I'm going to walk you through who the folks are. We've got Dan Oss, who's the Managing Consultant of Energy and Environment Economics, Inc. He's going to kick us off here in a minute with his expertise on the economic side. Go to the next one. And Jamie Mandel is the Managing Director at RMI. Everyone knows RMI, so he has a real focus on building program and cost-effective and market-based solutions. And Marco Petroni with research scientist at LBNL. And so I think the National Lab folks are going to dive deep into the technology. And Paul Rhodes is Director of Engineering at RXR Realty. So as we did in the morning, we're going to have somebody with a real estate focus coming at this for us to blend out the panel. And then we have Eric Wilson, who's the Senior Research Engineer at NREL, again, more on the technology side. And Andrew Parker, also with NREL, they're all going to be on the technology side. That's the last one, right? All right. So I encourage you, by the way, I did all of those short scripts because nobody wants to listen to me read descriptions. When the slides are made available, I encourage you to realize who these experts are. They're all really kind of at the top of their class and what they're doing, or they wouldn't be on this panel. So many thanks to each of them for spending time to do the prep. That's really the most important, and to share what they have to offer with us today. So with that, we're going to go through a series of these. We're not going to break for questions in between. This is all, but I do encourage you, be thinking about what they're talking about from the technical basis, because that's really what we're then going to dive into. This is intended to get our juices flowing and get us all with kind of a baseline of thinking going before we actually dive into a conversation. So let's get started, and I believe Dan is first. So welcome, Dan.
I appreciate the introduction. Am I just going to ask you to advance the slides when I'm ready? Is that the best way to go?
Sure.
Great. All right, so you can just go to the next slide. Thanks. So my name is Dan Oss. I work for a company called E3. We're a San Francisco-based energy consulting firm, though we do have offices now in New York and Boston, so we have a presence in the Northeast. And my goal today is to talk about electrification and peak heat, both drawing out the challenges and solutions of that peak heat challenge, which I'll get to defining in just one second. Next slide, please. But 2 key takeaways I want you to draw from this talk are that 1, heat electrification holds potential to drive large new infrastructure investments to serve peak loads, particularly winter peak loads. But don't panic, there are solutions. And those solutions will rely on a number of different measures, but I'm going to talk about 2 main ones today. The first is energy efficiency and how critical energy efficiency will be to make zero carbon neutral buildings a reality. And the other is offering that perhaps there'll be room for hybrid approaches that use a combination of electricity and some sort of backup in existing buildings. Next slide, please. So what is the peak heat challenge? The major challenge with peak heat is that the load the energy system serves, particularly for heating, is very seasonal. So our sort of peak to average loads for heating buildings can exceed a factor of 5 or more. And what that means is today our natural gas and fuel oil delivery systems are sized to meet that peak load. So our gas systems have enough capacity and our fuel oil delivery systems have enough capacity to deliver peak loads. And on this chart, what I've done is put those different fuel delivery systems, both building thermal delivery in natural gas and oil and electric, on the same scale in gigawatts hourly during 2015. And what you can see is that on peak, our building thermal loads dwarf our existing electric system capacity. So the key takeaways is we'll need to think about how we're going to manage that capacity challenge during those really, really cold hours of the year. Next slide, please. But heat pumps can heat efficiently, even in cold weather. So what this graph shows is we've taken that building thermal load and just assumed that we can get something on the order of a COP, a coefficient of performance of 1.5 during the coldest hour of the year. So we've really trimmed the amount of energy that needs to be delivered to a home or building by a lot, but we're still looking at a pretty high amount of electric load relative to that image we just saw on the previous slide. If we can jump to the next slide, please. And this puts this in context, just adds that heating load from the previous slide to the electric load from 2 slides ago. And what you can see is if we were to just do this sort of naive, reasonably efficient electrification, we would have 60 gigawatts of new firm capacity needed to meet peak loads in the cold year, which is roughly double the current capacity of New York and New England, which, sorry, I have to clarify, is what I'm showing in these graphs. So that is clearly a substantial challenge, but not one that we can't solve. Next slide, please. So this example is showing perhaps one strategy to do that. How can we manage these peak loads with energy efficiency? And in our modeling, all we've really done here is assume 2 things are different. The first is that we've assumed best available air source heat pumps are available today. So we're having a COP of greater than 2.5 on peak. So that's a COP of 2.5 below freezing, effectively. And we've assumed that there is a sort of widespread attempt to weatherize and do essentially measures that reduce the thermal demands of buildings. And between those 2 measures, we've achieved, by stroke of modeling fiat, a 50 gigawatt reduction in winter peak loads. So you can do a simple sort of back of the envelope calculation of what that would, what the avoided cost that would enable in terms of generation, transmission, and distribution capacity, and you get to a number that is over $10 billion a year. So that's one strategy to mitigate peak heat challenges. Next slide, please. But hybrid heat pumps could also be an alternative strategy. And what I mean by hybrid heat pumps are heat pumps that use a air source heat pump during the vast majority of heating hours during the year, but rely on a furnace or a boiler for peak capacity provision. And this is an interesting idea that is getting more and more attention in places like the United Kingdom, where we're sort of thinking, okay, we have one energy system that's already sized to serve this peak load. To what degree should we think about taking advantage of that? And what are the trade-offs in a broader economy-wide carbon neutral context? So what would it take to achieve carbon neutrality if we still had some backup heating in homes? One potential reason why the strategy could be worthwhile is it doesn't require a sort of door-by-door, house-by-house set of building retrofits. So it's sort of a trade-off between deep retrofits and maintaining our existing fossil fuel delivery infrastructure for peak provision purposes alone. There are a number of other strategies that I don't have time to go into today, but for instance, you could achieve a similar result using ground source heat pumps, which don't have the same sort of efficiency degradation as a function of outdoor temperature as air source heat pumps. So there will certainly be a role for those. And then I think my colleagues on this panel will be going into this in much more detail, but load flexibility will certainly play a substantial role in helping us think about how can we shift load away from those really, really strained hours from a capacity perspective. Next slide, please. So to conclude, just given sort of a high-level description of I guess I'm trying to put the stakes out there, that electrification of heating, achieving carbon neutral buildings will increase winter peak demands, but those peak challenges are solvable through strategies like energy efficiency hybridization, and as well as some of the other measures that I didn't go through today that my fellow panelists I think will cover in some detail. So that's it for me in this lightning talk. Thank you very much for your time, and I'm looking forward to the discussion.
Dan, thank you so much. I appreciate that. I'm sure that folks may have some follow-up on that when we get into our discussion mode. So Jamie Mandel, you're next. Caroline?
Great. Thank you. And I'm happy to be following Dan. I think I can build on a lot of what he covered. I guess next slide. So I'll be talking about the role that grid interactive efficient buildings can play. I have a few key messages to run through. I think at the beginning, this repeats what Dan said. Electrification will increase load and shift peak times, most likely to the winter. An increasing amount of variable renewables on the grid will make the timing of electricity use, especially peak, more valuable. And without coordination, simultaneous investments in both electrification and a variable renewable electricity supply can increase the total costs. We believe very strongly that grid interactive efficient buildings can play that coordinating role, and so lower the capital needs for both electrification and a low carbon electricity supply. We analyzed, and we'll go through a GEBS analysis for a DOE reference building in New York under current rate structures, and can show sort of both the value and potential measures. And then we looked at a high level at dispatching that same flexibility against wholesale grid costs and carbon, and saw benefits for both. So we think there's additional value as well. And I'll talk, if there's time, a little bit about low carbon rate structures, or rate structures that can support a low carbon grid. Next slide. So this is a New Jersey example, not New York, but we hope is similar. The point on the left is that electrification will decrease fuel use relatively substantially. New York might move faster than what's shown here based on their goals. On the right, it also shows that electrification, while reducing fuel use, will also shift the timing of peak to winter months, which Dan made pretty strongly. Next slide. Building peaks drive grid peaks, and electrification will make this even more true. So here what we see is annual electricity demand at a national level. We see, a potential substantial grid infrastructure is being spent to meet peak demand being caused by buildings that occurs less than 1% of the time, making those peak times the most expensive and likely carbon intensive power source. So when we look at grid interactive efficient buildings, managing those rare peaks becomes really critical. I would say even within the context of high seasonal peaks, which Dan talked about, this ability to manage coincident peaks that occur during short periods of time will have substantial value in lowering investment costs. And I would lump EV charging, so electrification of mobility, into the same trend. Next slide, please. So grid interactive efficient buildings can help buildings shape load profiles in beneficial ways. I think demand response, I would say, is a subset of this, but in many cases, this is an opportunity to have consistent load shaping without impacting residents. So on the left, you have a typical commercial building. As you move over to the right, you look, a grid interactive efficient building should have both a low and often a flat load shape, or one that can respond to signals. Next slide. In New York City, we looked at a 500,000 square foot DOE reference building, a commercial office, and found that even in an electrified heat pump scenario, grid interactive efficient buildings can provide substantial savings using current rate structures. What you'll see is a lot of benefit comes from an efficiency measure, increased air filtration and reduced ventilation. But staging air handling unit fans and staging your heat pumps, if it's a multi-zonal or multi-unit heat pump, which was assumed here, can have pretty dramatic benefits. You'll also see LED retrofits being substantial. So roughly half of the benefits are coming from flexibility, half from efficiency, which is what you would expect. Next slide. So you can apply those same flexibility resources to locational marginal pricing in Zone J. We did this kind of at a spreadsheet level and hope to go much deeper. And I guess we'd say there's substantial potential grid cost savings if you can dispatch this effectively against grid costs. What we found is it was comparable to the building owner value that I showed on the previous slide. We haven't yet estimated the full potential savings stack, and so I don't have a chart here to show you today. Next slide. You can dispatch that same flexibility against emissions. Our colleagues at WattTime did this analysis, and I'm sharing their slide with permission. Right now, there's relatively low marginal emissions differentiation in New York, but we expect that to increase pretty dramatically as renewables increase on the grid. Even so, you can see with relatively limited flexibility, an increase of 2 to 3% in emission savings by dispatching flexibility against that. Next slide. So what do we think about all of this? I think at the building level, investing in fully controllable systems becomes really powerful. Thinking about demand management in a consistent way as opposed to an event-driven way like DR, I think is really useful. Storage plays a critical role in figuring out how to incentivize and clear the red tape for more storage can be pretty valuable, both thermal storage and electrical storage. And thinking about tailoring rebates and incentives to really focus on the measures that can provide flexibility as rate structures evolve. Next slide. I'll conclude here really quickly. If we look at emissions, having rates that tie to emissions as you decarbonize the grid can make a lot of sense in lowering costs. We don't necessarily know when periods of high and low emissions will occur ahead of time. And so creating a dynamic flexibility as opposed to static flexibility, so leveraging controls in addition to efficiency measures can be really valuable. As curtailment starts to become an issue on the grid, you're going to see the greatest emissions benefits shifting from reducing peak demand to reducing curtailment, and figuring out how to create rate structures that can manage both needs simultaneously will be important. So we do see good correlation today between wholesale price and emissions. So there's an opportunity to tie those together and begin building emissions responsive rate structures that buildings can respond to already. And that sets a foundation for evolutions going forward. And I will wrap up there and thank you guys for the time.
Jamie, thank you. That's really helpful and continues to build a nice foundation for us as we move forward. Marco Petroni with LBNL is next.
Hello, can you hear me?
Yes, absolutely. Welcome.
Okay, so I guess next slide. So I'm a scientist at Lawrence Berkeley Lab, and I work mostly boot on the ground, so on implementing the things that you guys wanna you're talking about. And this is the way. So in 5 minutes, this is my way of conveying the challenges in actually doing it. The way I think about electrification is that and we all know why we're doing this. Mostly driven by trying to decarbonize our system, you'll have an impact on the grid. As we say, we have the duck curve there in California on the right, and the alligator curve. There's a bunch of other animals that you may be familiar with or not, but these are problems that are currently occurring. They're not in the future. 2020 is like in a month. The other piece that is impacted by electrification is reliability and resiliency. So you see the fires in California and people trying to fix poles. I don't know how many of you know, but there was so PG&E went bankrupt a few months ago due to the fires. I was personally affected by the power shutoffs, which happened to minimize risk for PG&E, which could be financial risk or actually fire risks. But what happens is you're stopping electricity. And I was lucky I had the gas system in my house, so I could take a shower and wash my 2-year-old. But if you don't have that and you go complete electrical, you have to think about storage in some way. So next slide. LBNL does a lot of research on grid interactive buildings, both for DOE and for other agencies, including California Energy Commission. We have a lot of history in demand response. Marianne, who's my boss, has done demand response for 20 years. We have a great team that does advanced controls and analytics. We create open source software that people can pick up and use. We look at microgrid storage and other things. So you can see here on the right, there's a couple of diagrams from the GEB report that was mentioned before by other presenters. And on the top, there's like different type of grid services that were developed for a demand response potential study in California, from shape to shift and shimmy, all type of changes in the load shapes that buildings can adapt to. Next slide. Having only 5 minutes, I want to talk to you about this project we have in California, where we took a gas station in a fairly remote area in California, and we said, okay, how can this become a center for resiliency? And it's in a place that has both storage and efficient use of electricity. And the reason why we're doing this is because there's tons of gas stations around around California and the US, and with the EV revolution, that may be turned in the future in centers of charging for EVs. In addition, they become centers for people that are in emergency to go and get their fuels and do other things. So we created a microgrid at gas station level, which is fairly small. This creates a bunch of challenges that are mostly due to the fact that the costs for connecting to the grid for a microgrid are incredibly high, around $50,000 to $100,000 for engineering and materials and etc. There's very few options for controls of these buildings in existing commercial systems. And even if you can get a battery from one vendor and PV from the others, and maybe a control system for the building, they don't really coordinate. Next slide. Yeah. So what we have done is, this is our partner. We're partnering with Humboldt State University and an Indian tribe in Northern California. We took this gas station, deployed PVs. We control the freezer and the fridge, walk-in freezer and fridge, thermostats, and rooftop units. We control batteries, and we develop a software stack that is open source, and there's also a piece of hardware that can decrease the cost for deployment of the system. And next slide. This is, why we're doing this, why we're obsessed with gas stations or small buildings. Well, because, gas stations are a central piece of the critical infrastructure. You can see people getting energy, water, food. There's a, small convenience store on place. There's really a need for resilience packages for fuel stations and convenience stores that are not available now. And they can also be scaled up very quickly because a gas station is fairly similar to any other gas station. A couple of events to give you an idea of why this is critical. This is 2018. Gas Buddy had a list of stations in North Carolina where you could have both fuel and power, and none of them had both both of them. So it's a real serious problem. Another thing is, this is the power shut off in California a few months ago here. 700,000 people were affected, and you get no power, no nothing. And having battery systems and something that can isolate and work independently from the grid becomes fundamental, especially if you're completely electrified. Next slide. So I'm gonna end with technical challenges. So we do a lot of simulation also here at the lab to establish what is possible and what is not, a big picture. But what I'm trying to convey here is there's a lot of technical issues at the lower level where both technical products are not necessarily available, the economics are not necessarily there, there's a very high capital cost. And I'm talking about mostly small commercial buildings, but it's a different type of problem for residential, small commercial, and large commercial. On the policy side, the cost for interconnection is very high. In addition, and this is also something that DOE is working on, is very hard to measure flexibility. So somebody mentioned before, putting this in code, and I agree that would be great. But measuring efficiency is fairly easy. You can sum it up, everywhere. But flexibility has a spatial and a temporal component that make very hard to define, what your profile should be and what your behavior should be without knowing data for a specific. So this is my contribution. Thank you.
Thank you, Marco. Let's see, Paul Road with RXR Realty is next.
All right, thank you.
Paul,
Yeah,
turn the mic on, please, and keep it close to you.
Okay, thank you. So forward one slide then. I'll start the discussion with, and if you could just, flip all the items up. I'll start the discussion with the electrification of commercial buildings from the perspective of an operator and developer of large commercial buildings here in the suburbs. I first have to say that our primary focus is on density and on providing an environment and a space for our tenants to perform in. All right, so the buildings exist to create business opportunities for the tenants to execute on that business. And so we are completely focused on providing these contracts that allow that to happen. Taking a step back from that, we do believe that there's still a tremendous amount of waste in the existing building stock and in designs of new buildings that can be wrung out, and that can be easier to bring out, obviously as we design buildings from the ground up. And we see those new designs incorporating items that allow tenants themselves to have zero-touch mechanisms or processes that will allow them to use just the energy they need at the point they use it without thinking about it. So the development of what I call zero-touch tenant energy management systems will be paramount in these buildings and actually adds the flexibility that we've been hearing about. I also talked about flexibility, or mentioned flexibility out there. What I mean by that is space flexibility. The idea of being able to reconfigure space instead of redeploying tenants when they've changed their business functions is extremely important. And also developing shared services or shared floors in buildings to reduce energy. So having sort of all the pantries located on one floor instead of a pantry in every tenant space actually does save a tremendous amount of energy, is more hygienic, and moves us towards the goal of lowering the electric envelope to allow room for heating to crowbar its way in there. Use of passive measures. In new buildings, this is the opportunity to have high-performing wall systems, having natural lighting systems, heat recovery, and again, and wellness measures built in. We see this as a paramount initiative among all new buildings, and now, frankly, easier to quantify than in the past. Also, on the technical side, all our new buildings are going to have a much finer look at what we call turn-down ratios, or the ability of the equipment to provide its conditioning just where it's needed, as opposed to half the building, and one extra space. And we find that buildings are used now much more than they were in the past. In the past, you go into a building at 7 o'clock and only run into cleaners. Now you'll go into the buildings and, at 9, 10 o'clock at night, and they're still fairly well populated, but the building systems to support that population are wasting energy. So we wanted to have systems that match the use of the other tenants in the building. And frankly, there's a number of systems I can talk about that achieve this. The other few items I'd like to talk about is controls, use of controls. We've heard about it somewhat before. The control industry, unfortunately, is still segmented. And there are environmental controls, there are elevator controls, there are card access and metering. And in order to achieve a more optimized use of energy in the building and allow flexibility in load management, we're going to need to integrate those controls together. And that is happening right now. And the integration doesn't necessarily have to happen at the building level. In fact, I think it'll probably happen at the cloud level. And building controls, frankly, in the future are migrating towards the point where the analytics and the control logic is in the cloud and the points are in the building, and it's to work with each other with some sort of mechanism to protect the building from communication outages. And then, obviously the big question of the room from a thermal perspective is electric facilitated heating. I call it that because obviously what we would try and do is use DR systems or air-cooled heat pumps, water-cooled heat pumps or geothermal connections. The idea, obviously, is to stop burning fuel in the buildings and not setting up new buildings that way. And then finally, we don't see many new buildings started or get out of the design development stage without serious consideration for electric and thermal storage. I do draw a distinction. And for thermal storage, I am also including thermal heat storage as opposed to thermal storage for cooling, geothermal, solar, and power management systems. And power management systems I put on there because I do believe from a resiliency perspective down the road, not immediately down the road, but maybe 10 or 15 years down the road, we're going to, from a building owner perspective, have to contend with a grid that may not be as stable locally as we're used to. And, or even our own building with all of these assets that pull power and push power into the local spot networks and into the local utility networks, we're going to want to have industrial level power controls that will allow us to do frequency stabilization, better load management, and just have a much more robust control over what comes into the building and what leaves the building so that our tenants can stay doing their jobs. Please go one step further here. Now, existing buildings are slightly different. Same focus on the tenants, but I don't have as many tools available to me to deploy these buildings because they're fixed assets. That being said, zero-touch tenant energy management strategies is still a field that we have to push into. And by the way, second time I've used that term, zero-touch, is because we've tried the last 5 years to have tenants brought into the energy management process. Is very, very hard to do. Energy, from a tenant perspective, is a very small cost compared to rent. And it's not their business. And so what the tack we're taking now is develop these programs that they really just have to sign up for. And then we go ahead and the classic example that would be going to, sort of an egress lighting and just, or like a functional occupancy mode during a demand event or event when we want to pull energy out of their space, having us help them design their space so that there's not half a dozen supplemental systems running all the time. It's just what they need when they need it. So just moving down the list here, incremental deployment of passive measures with fit outs and major restorations. I think we heard a reference to that before, that the opportunity in existing buildings is during major retrofits and during tenant fit outs. And then the good aspect of making the buildings basically easier to heat can be done very incrementally. It can be done a floor at a time, a space at a time. And so I don't have to do the massive recladding the building. I can sort of reclad from the inside the building and get good incremental results at a marginal cost increase that makes sense from a payback perspective. Energy efficiency, it's interesting. Looking out 5, 10, 15 years into 2050, I still see energy efficiency as carrying the day from the perspective of protecting the asset value of these buildings. And that is because I do think there's going to be a lot of cost pressure on the cost of power. And in order to mitigate that, we're going to have to bring all of the waste out that we can. And so we will do that by continually looking for ways to lower the load. And that's lighting, HVAC, power management. Again, I go into deeper use of controls here as well in existing buildings. And existing buildings lend themselves to the Internet of Things type approach, in which we have existing systems, but by connecting them up to some cloud services, we can have better coordination between the different elements. And what I mean by better coordination is, lighting just on where I need it after hours, knowing that the peak of the building during the day, we all are familiar with these building curves. But what worries me not so much is the peak during the day, but it's the trough during the night. Why do I have 5 megawatts on at 1285 Avenue America is at 2 a.m. in the morning? In the daytime, it's 10 megawatts. I don't understand that. So we want to find ways to pull those things down. A big tool will be broader and deeper use of controls. Gas, any buildings that are heated by oil and steam, most of ours are steam, are going to remain that way until the buildings age out or the penalties on using gas becomes onerous that it pays to swap out an electric boiler. That being said, the buildings are looked at from the standpoint of thermal storage, geothermal, solar power, the same suite of things for new buildings we'll look at for existing buildings. Just progress one page, please. All right, residential buildings. So And I just have one slide on these for new buildings. We're building 70, about 7,000 or greater number of apartments in and around Manhattan. Siting of the buildings is very important from a load management perspective, partly because you put your buildings basically within walking distance of transportation infrastructure. You're at least allowing for the tenants in the building not have to have a car to commute, and you're allowing for yourself not to have to build the infrastructure to support them having those cars. So siting of the buildings becomes a measure as much that we have to think about as much as anything else. Again, use of passive measures, high efficiency windows installation in these buildings to lower the heating load as much as I can prior to applying electric. Heating from air-cooled heat pumps, we're seeing all sorts of innovations come out, CO2-based heat pumps that, obviously it's not an innovation, it's geothermal heat pumps. People are talking about them now as if they're innovations, but we see great promise in that and are deploying that ourselves. So, electric boilers or resistance coils at some point will be what you're looking at if you're in a moratorium zone. I know that, the moratorium has been lifted, but we would actually move to an electric solution before going to an oil solution in some of our new buildings, just from a future-proofing perspective. Control of touching all energy-consuming equipment in buildings. It's absolute must in residential buildings. Most of the staff there tend to be leaner, and more of the thinking about what happens with the central systems has to be done automatically. Zero-touch energy involvement programs, basically that's your nest type arrangement with the thermostats and the tenants in the buildings, but enabling everything for them. So they literally just say yes on a monthly rent statement, and they get to participate in a program, and something good will happen for them. And thermal or energy storage and solar, again, another component here in these buildings. So we're seeing on existing buildings, the new buildings, commercial and residential, we're seeing that we're really looking at every one of these buildings and seeing where we can apply some solar and some thermal storage. The tricky part here is trying to figure out how to model the return on investment for that, because we're making guesses about where the cost of power will be. Slight changes in those assumptions cause these projects to look very good or very poor. So hopefully we'll get some resolution on that in the near term. Just go one more slide, please, and bring these all up. So now I'll talk a little bit about grid modernization for the electrified buildings. A couple things from an operator perspective, and this is, I will say, more commercial oriented than anything else. We are nervous that, as people migrate to electrified buildings over the next 15 years, the grid will be under stress. And there's a lot happening to this grid. I can't be the only developer thinking about putting solar up on these buildings and doing power management systems. And so my neighbors are doing things different. The grid is going to be fed, differently, let's say. And so, we have to insulate ourselves from what could happen to us, outages, crazy frequency imbalances, voltage dips and sags. And so that's first and foremost on our mind right now. We do believe we're going to have buildings very shortly that will be able to demand limit or load limit at a much greater volume than they currently do. In fact, demand limiting in most commercial buildings now is sort of a very passive item. It's, what can you do without affecting any tenant or anything you can see in the tenant space? But when we pull the tenants into that equation, and as we design these buildings to be able to hold down systems for greater periods of time, you'll see deeper pockets of reduction, like we saw on the chart from RMI, and that will have an effect on my neighbors and on the grid, and we'll have to have systems to deal with that. The grid will also have to be reinforced to accommodate swings in power and frequency that we're going to see. Currently, the grid is somewhat fragile in parts of Manhattan. Where it's underbuilt, it's a problem. It's just going for an interconnection agreement a couple of years ago when across Manhattan, these different spot networks, you learn by the degree of work that the local utility has to do how fragile some of the connection points are. So I do believe the grid will have to be reinforced, and it'll have to be reinforced from the perspective of a proportional bidirectional flow in and out between nodes in the grid. There might be periods of time, in the middle of the night when my commercial office building is actually discharging. I mean, the rule of thumb is that, you know, if I have a battery system, we'll be charging at night, discharging during the day. Well, it may turn out in the wintertime it's discharging at night because it's surrounded by some residential building. And then, you know, and again, as a major protector against grid anomalies, power quality metering is going to be an absolute must. We're going to have to look at more than just the load. We're going to have to look at the waveforms, phase angles, all the metadata that comes with the power, so that our in-house systems can combat what might be happening that is improper or not productive to keeping the building going, to keep the tenants safe. And finally, on communication infrastructure, you know, right now we get power, and if we want to do demand lending, you know, we get a phone call and an email. That's completely ridiculous in an age of continuous interaction with the grid. So, I mean, we do foresee, local pricing being established at a much more granular level, and the buildings collect data. And while the utility has to serve our building, you know, we will also have the opportunity to push back into the local node and do what we can to advantage a set of prices or a set of calls that the grid has. And so demand frequency response programs at the building level, followed by pricing, followed by communication streams that go with the power. So we'll get power, we'll get a communication stream that our systems can work with, and probably a business system that's real time as well, will enable us to justify the project investments that we need to build this out on our side. That's what I have. Thank you.
Great, thank you all very much. Let's see, I think last we've got the tag team of Eric Wilson and Andrew Parker, both with Enro. Welcome, guys.
Yes. Hello. Can you hear me okay?
Yeah, welcome.
Great. This is Eric Wilson, and my colleague Andrew Parker is joining me. And we're going to be kind of taking things up in scale and talking about our work doing building stock modeling to look at electrification, large-scale electrification of the building stock and impacts on the grid and resilience.
Just let us know when you want the slide to go forward, okay?
Great, thank you. Next slide, please. So I'm going to start things off by going through little example of why we think it's important to do modeling of the building stock. So
Eric, you want to be on 64 or 65?
Yeah, this 60. Sorry, it wasn't updating. Yep, this is great. I'll talk from here. So just to do this illustrative example. Imagine you have a neighborhood or a single ranch home in, say, Chicago. Could be New York, but I'm using Chicago weather here. And look at a cold week where it gets below 0 Fahrenheit out on, as you can see on the graph below, on that January 29th day. And you say, okay, let's electrify this home. It has a gas furnace. You can see the whole home electric load on average for this neighborhood on that January 29th day. For a gas furnace, it was, very low. Maybe it went up a little bit because of the furnace fan is running. And then if you just electrify with an electric furnace, you get that first line up there. When you can see a huge peak on that January 29th day. Of course, putting in an electric furnace isn't very realistic. So let's put in a heat pump. And say it's a minimum efficiency heat pump where if it goes below 0, then you're basically resorting to using an electric furnace. So you're spiking just as much as that electric furnace case, and you're actually making your peak to average ratio worse. There's more ramping going up to that cold day. Well, let's try another heat pump that's kind of top of the line efficiency. If you could move to the next slide.
Eric, let me just stop you for 1 second. Would you go back to the one that says gas furnace? There you go. I don't know, so are you able to see this, Eric, in real time?
Still on 66.
Okay, so what I'm wanting, only because on our screen, as you talk through it, all the other colors except the dominant one washed out. So if you could just talk through the gas furnace again, and then we'll move the slides with you so that people can kind of get the effect of your slide.
Yep, will do. Yeah, so here, this is showing the gas furnace case. The home, the 1950s ranch home or neighborhood of homes, starts out with a gas furnace. This is the whole home electric load. So you can see it's kind of in the 0 to 5 kilowatt range. Even on this cold day, it doesn't take up that much. And if you go to the next slide, 65. 65 is going to show what happens if you just swap out that gas furnace with a electric resistance furnace. So it peaks up around 40 kilowatts, which is kind of ridiculous for an individual home. And I'm still seeing 64. Oh, okay, 65. And then if you could go on to the next heat pump slide. Yep, great. So so this example is showing with, say, a cold climate, top of the line efficiency heat pump. So you can see that you've reduced that peak that you got on that cold winter day by about half. And the efficiency gains on those milder days are even greater. But still, you could get some issues with the distribution grid if there's all the homes on a block that are putting in even top of the line efficiency heat pumps. And I didn't model ground source heat pumps, but that's something that we can model and look at. But we can also look at what happens if you add on some energy efficiency measures, improving the envelope of the building. So that's what the next slide 68 shows. If you do some really aggressive air sealing and insulation measures as part of a package, and then you put in this top of the line high efficiency heat pump, you get a load coming out on this cold winter day. It's actually not too different from the original gas furnace, of course, on a large scale that we're seeing here. Okay, I'm still saying 67. I assume you all are seeing 68.
We're on 68 now.
Yeah, we're on 68
Yep.
now.
Great. So yeah, this is the results with that weatherization package. So all this goes to show, I'm sure many of you are familiar with the different technologies and different levels of efficiency of envelope can have a huge effect in determining what the load of a building is. And when we're looking at large-scale electrification, it can become very useful to model the building stock with these types of physics-based models to understand the potential implications of this large-scale electrification. So if you move on to the next slide. I'm going to be talking through models called ResStock and ComStock that NREL has developed for the U.S. Department of Energy. And these models are built on and use kind of core simulation engine capabilities and the Energy Plus tool, as well as the Open Studio SDK abilities that kind of layer on top of Energy Plus to make it easier to use. And those tools are both designed to model individual buildings. And then NREL is also developing a tool called UrbanOpt to model districts, which leverages the Energy Plus and Open Studio capabilities. But I'm going to be focusing on this third scale, trying to whole building stock at a whole city level, state, utility, territory, or national level. So if you can move on to next slide. And advance to 71. So ResStock and ComStock are highly granular analysis tools for modeling the building stock at these different scales. And I'm just going to talk through briefly what sets these tools apart from other approaches. Let's move on to slide 72, please. So there's three key components that make up ResStock and Comstock. One is advanced to 73, a detailed database of the characteristics of the building stock at these different scales. We've compiled a set of dozens of data sets, large public and private data sets, that define all of the building characteristics that affect energy use and occupancy patterns in the building stock, and structure these in such a way that there's this tree of conditional probability distributions that we sample from to generate hundreds of thousands of representative building models that represent the diversity in all those different parameters that make up the building stock. And then we simulate those. If you advance to 73, I think should be on now. We use physics-based computer modeling to do detailed sub-hourly energy simulations of all of those represented buildings, and then advance to 74. At this large scale, we need to make use of modern high-performance computing resources, whether that's the supercomputer we have here at NREL or cloud computing, in order to simulate this large scale of simulations. So what are the applications of these tools? Move on to 75, please. So there's a number of applications. We've been working with utility companies and utility company consultants to look at how they can increase the cost effectiveness of their energy efficiency programs, and also understand maybe there's ways that they can defer the distribution infrastructure spending in parts of their utility service territories. And then for manufacturers, say of emerging technologies, we've seen interest in using these tools to really evaluate what do some market research and understand what the potential revenue is for different technologies. And maybe that can inform, is there one state or city where they want to spend some more dollars in terms of marketing or sending salespeople there. And then finally, cities and states and as well as building owners are interested in using ResStock to identify just the highest priority, most economic upgrades that can be made to the building stock, whether that's a portfolio of buildings or all of the buildings within a city or state. And then rolling things up, understand how all those buildings and the efficiency gains that can be made in those buildings, how that can contribute to aggressive energy or emissions targets. I'm going to talk through one specific example on that last application. If you advance to the next slide, please. So NREL has been working with the City of Los Angeles and the Los Angeles Department of Water and Power on a study to look at look out at options to get to 100% renewable energy by 2050. And this is a first of its kind of analysis, and that we're doing this really detailed building stock modeling that's feeding into a lot of simulations of the electricity grid. And the key question that we're involved in is really trying to understand what role that buildings play in achieving 100% renewable energy, both for the city and the utility, since it is a municipal utility, and accounting for various factors in the building stock, the growth of different sectors or building types over time, the large-scale electrification and how that plays out on and impacts the electric grid. Efficiency levels, looking at different aggressive or less aggressive levels of energy efficiency deployed throughout the building stock. And then finally, flexibility, trying to understand how flexible buildings, the demand from buildings can be, and how that plays out in terms of making it easier or more difficult to achieve their renewable energy goals. And moving to next slide. So this building stock modeling that we're doing is kind of feeding into all other aspects in modeling for this project, and really understanding where it might be necessary to make grid infrastructure upgrades, how buildings affect the need for critical transmission investments, maintaining system reliability, as well as the impact on equity and jobs and the local economy. So that's one example where we're doing kind of this building stock modeling and projecting out in the future to get different scenarios and understand what are the large scale impacts of particularly electrification in a place like Los Angeles. It's not going to have as big of an effect as a place like New York. So it's going to be really interesting to see as we start to deploy these tools in other places and understand some of the impacts of electrification. And finally, moving on to the next slide, I just want to put a plug out there. We are now working on a project funded by the U.S. Department of Energy where we're seeking time series data, all different types of time series data to be able to calibrate and ultimately validate the res stock and comp stock models and their ability to produce accurate end-use load profiles for the building stock for the whole country. And we're going to be doing kind of deep dive calibrations in different regions. So the more data we have from a particular state or region, the better we're going to end up in terms of calibrating the model. So I wanted to put it out there if anybody has any ideas on where we might be able to get access to whole building interval meter data, say from utilities, as well as customer class hourly load shapes for utilities that kind of, it's aggregate across many buildings. Still is useful for a project, though getting the building by building data is what we really like to see. And then we're also starting to look at going after commercial building automation system data to be able to calibrate some of the end uses, as well as measurement and verification study data, and then other end use submetering data sets that are out there for the different end uses, HVAC, water heating, lighting, refrigeration, plug loads, et cetera. So please reach out. Our emails are on the next slide. And NREL has a history of working with sensitive utility data, and this data is going to be kept anonymous. We're just going to be using it to compare against our models. And we do have some budget available if the data is kind of meets a certain need that we've identified, fills a gap that we have, then we have some budget available to assist with the anonymization process or transferring the data to us. So please do reach out. We'd love to work to make our models better and more useful for New York. Finally, thank you. Andrew and I, our emails are there. And then I just want to mention that we have a case study that came out recently looking at how cities such as New York City can take steps to prepare for a detailed building stock analysis. So that's up on the ResStock website under publications. So feel free to check that out. Thank you very much for your attention.
Great, thank you very much. It's good to have that sense of how modeling can be helpful across such a wide variety of the work we're doing. So before we skip into the discussion, though, let me just make sure we thank Dan, Jimmy, Marco, Paul, Eric, and Andrew. Paul, it's a heavy lift to get to spend your time to get this good information in front of us so we can now have a more robust discussion. And in case before somebody asks, we're going to ask each presenter if it's okay if we share their presentations, and presuming everybody says yes, we'll get those up online soon. So it is the intention to try to get, make these presentations available to you all going forward. So if you go to the next slide, we now have about 35, 40 minutes for a robust conversation. Really, first looking at this question around the technical considerations here that we've got listed for large-scale electrification of buildings with a modern electric grid. So we've heard a lot of needs and tools and opportunities and barriers through all of these conversations. NYSERDA has pulled a few barriers together as well for us to think about as we walk through this conversation. They're up on the screen here, but just to quickly hit them, there's the questions around upstate, downstate divide, the cost and value proposition, just awareness. People don't really realize that there's an issue here to be solved, and it's complicated. So a lot of questions around data. That I'm not going to read them all to you. There are technology issues, particularly lack of interoperability, We heard about the evolution of controls that we're in the middle of many times from the presenters. There are implementation barriers moving forward. We've heard some of those. With all of these Internet of Things, there are always going to be cybersecurity issues and to think about. And then the issue of workforce always comes up. Do we have the trained workforce we need? So as I get ready to kind of open the floor here, with those in mind, you know, what we're really trying to encourage is that you give us your ideas of what you think the barriers are that you encounter or you're aware of. I'm trying to really build out off of these presentations, and I'm going to try to, you'll see in groups of 2 or 3, I'll take some from here in the city and some online, some in Albany, and I'm likely to try to not come back to the same person over and over while there's new people trying to enter a dialogue. Those of you that are shy, they're sitting in the back, find your voice at some point and work your way up to the microphone, and I'll call on you too. So who'd like to open the discussion here? Here in the city, let's start here in the city. Anybody? Let's go to you. And just to remind, introduce yourself, name, who you're with, and then please dive into your comment.
Thanks a lot. Mark Suluwaga.
Push the button. Push the button. And then just so everyone knows, mic really close, because we can hear you if you're way far away, but folks online can't.
Mark Suluwaga with Stephen Winter Associates. Appreciate that chance here. I think we're talking about pretty unprecedented stuff, so I think it's worth looking back a little bit at some precedents we can cite. On the demand side, the only thing I can think of that's this level of change with infrastructure is the comfort cooling kind of change that happened in buildings. So it took 60 years to make comfort cooling go from 4% penetration in homes to 90%. So I think that just speaks to the fact that the electrification stuff needs to get pushed up aggressively. On the demand side, as I sent Craig the other day, I think it's interesting to go back to before I was born. It was in 1970 in New York City. So the city was grappling with peak demands were increasing close to 0.5 gigawatt a year because they were on the sharp S-curve with new AC adoption at only 50%. Obviously, there were a lot of reliability issues, and Con Ed sort of met that challenge with a plan in 1970 that they called the 20-year advanced plan, which basically said we're going to meet what we think the 1990 peak is going to be in New York City, which is 17 gigawatts. They were 8 gigawatts in 1970. And we're going to do that given all the constraints and improve reliability and all the regulatory challenges that sort of have, you know, they were aware of at the time. What ended up happening, fortunately, is peak demand is currently only, 11 gigawatts or something like that. So they kind of prudently overestimated. But the point being, there was a plan in place in 1970 to provide 17 gigawatts of power in the downstate market. And I think, I'm sure the challenges are different, but I think the one thing we have that's an advantage today is the benefit of time. There's a lot of headroom between the current summer peak and the current winter peak, both upstate and downstate. And I think that affords, from a planning standpoint, I would think a lot of time to sort of get the supply side right. And I think that's, you know, something to work with as a resource. In terms of like the actual kind of analysis, and I appreciate the presentation, I think it is very constructive to look at New York State differently in terms of upstate versus downstate. There's smaller buildings in colder climates with different construction costs per square foot upstate, and bigger buildings downstate with higher construction costs per square foot in a milder climate, and that can speak to different solution sets. And I would specifically call out when it comes to energy efficiency. I know a lot of the national conversation is very influenced by single-family homes, but in the context of a New York State roadmap and residential buildings that use all the fuel in downstate in particular, you know, an electrified building is inherently an energy efficiency building. The waste in our big downstate buildings is from tenants opening window behavior and distribution challenges, all of which are solved by delivering the right heat to the right, you know, spaces at the right time with electrification solutions. So heat pumps are an inherently 30% plus load reducing measure when they're implemented in bigger buildings. And I think that's kind of important to keep in mind. And once you do that, you have a pretty good building in place. I think just the reality in terms of looking at upstate versus downstate is the solution sets are just not there for bigger buildings. So I think New York City being winter peaking, I'm sure will lag upstate because it's colder upstate, and the technologies for getting heat pumps into bigger buildings are not not there like there are with small homes, and I think that's something to keep in mind as well. And lastly, from the standpoint of kind of the hybrid concept, which I love a lot, and it makes a lot of sense. I mean, I think there may or may not be a scale where hybrid, kind of having two systems to meet one function, makes sense. I'm not sure. Some owners you talk to don't want to have two systems, but if someone can figure out the business model, and that's great. I would call it certainly the bigger the building, the bigger the site, the more that hybrid concept makes sense. And I can't think of anything bigger than the power plant scale. And so I think from the standpoint of using gas for a few hundred polar vortex hours in the sort of gas peaker plants that are sited within New York City might be sort of the ultimate hybrid concept that's worth thinking of. And eventually, I mean, this is not my area of expertise, but once we get all those wind turbines and we're providing, maybe hydrogen for seasonal storage, I think, there's ability to go carbon neutral with that. But I would just extend the thinking of the hybrid kind of scenario to more than just the building scale. I think that's all I have to say for now.
Thanks so much. A lot in there, and there's this notion of kind of learning from the past and making sure we have appropriate plans in place, getting the supply side right, focusing on behavior and all the losses we're experiencing there. The idea of heat pumps is a real idea that's ready in certain markets. Those big buildings, we all know, have their bigger challenges and are hard. And this redefinition of what a hybrid might be and how we might use that in some useful way. Some of the key takeaways I heard there. Bob, why don't you hop?
Yeah, Bob Wyman. First comment on the winter peak versus summer peak. Sorry. Yeah, down here in New York City, we got, there's a big differential between the summer peak and the winter peak, and between either of those two peaks and average load. But it is important that people recognize that we have two load zones in the state, load zone D and E, that's North and Mohawk Valley, which are currently winter peak. And so that we do need to look at the different parts of the state differently. To follow up on what he was saying about hybrid, I must admit this concept has always sort of puzzled me, and I know Mr. Oz comes from California, so maybe things are different there, but the problem, one of the big problems we have with gas here in New York City is the gas demand. And a hybrid system essentially would be adding incremental gas demand on the coldest days. So it would be relieving electric demand on the coldest days, but it would be increasing gas demand on the coldest days. And frankly, I mean, we already have a massive problem with peak demand on the coldest days right now for the gas system. So we have to understand that a hybrid system is going to work better or worse in a load zone where you have to look at the loads of both the electric system and of the gas system. You can't just look at one. The other thing too is just there's a concern with the hybrid approach in that one would, because a hybrid system, it wouldn't be generating much gas revenue over the year. It's very unlikely that a newly installed hybrid system would, over its lifetime, generate sufficient revenue to be economic. In fact, a good investment by the ratepayers. And so one would be concerned with encouraging such an approach, say oil to hybrid conversions, because the infrastructure that's involved wouldn't necessarily be paid off within a reasonable amount of time. We have to remember that in areas like New York City here, because of the 100-foot rule, well, in New York State, the 100-foot rule, nobody actually knows or feels the cost of installing the infrastructure, and it's spread across ratepayers. But here in New York City, the average cost, according to the filings by the utility, are about $33,000, up front, and then of course you have the financing charges, the salvage costs, and all the rest of that over the 65 to 85 year life of the asset. So putting in new assets can be really expensive. We have to understand understand that people are, if you're pushing hybrid, people are likely to ask for it because they're not going to be exposed to the cost. The costs are hidden from them. In any case, a hybrid system does increase gas peak demand during gas peak demand periods. Probably be considered by many to be an undesirable thing, even though it does potentially allow the electric peak to be reduced.
Great. So a couple of keys there, just a reminder to us all that within the state of New York, you have both summer and winter peaking zones. And on the hybrid issue, I would flip it the other way to say a current barrier is if you wanted to go towards a hybrid system and if that fit within the constraints of the law to actually largely decarbonize, then you have constraint issues that you have to overcome in order to even consider hybrid. So it looks like you wanted in, Damien?
I'm sorry, yes. Yeah, thank you. Damien Ciano, close. Damien Ciano, hello. I'm the Director of Distribution Planning for Con Edison. First of all, thank you for this opportunity. I've already learned a lot. It's a great time to be a part of this, and I'm very excited about it. Obviously, as a company that's electric, gas, and steam, we do, see the hybrid model as making the most sense for our customers. There's still a tremendous amount of opportunity to move the 50% of customers from oil to gas. And in addition to the 50% carbon reduction, you're getting reductions on SOx and NOx and particulate matter, et cetera, and so on. And while it's true that there is certainly a winter peak for gas, certainly as you're doing the electrification, you're creating some headroom in that gas system. And most of the models we've seen when we look at our long-range planning kind of show the need to have that base gas in the system there just exactly so you don't have to triple your peak using resistive heating, essentially, as we saw in those presentations. So, I appreciate the comment about it's actually 13 gigawatts for the Con Edison territory in the summer, and it's about 9 gigawatts in the winter, just to give everybody kind of that perspective right now. But I think the point is exactly right. The fortune tellers back then saw it as much higher, and I'm sure we'll solve most of these problems. But there's two main issues that we'll have to kind of wrestle with as we come up with this roadmap. So again, laying out the timing and certainly to the extent that there's clarity on whether it's a hybrid approach or just an all electric approach is kind of critical. So those two issues are, I'll state the less obvious one first. When we schedule outages now, we basically have 9 months for the generators to take outages, for the large transmission lines, et cetera, because we're shooting for a summer peak. When we start crisscrossing that 13 gigawatts and the 9 gigawatts becomes 10, 11, 12, 13, that's going to dramatically impact our scheduling of outages. So there'll be some cost and need to handle that. So again, we can do this, just putting that out on the table. And then obviously, the model we choose is going to have tremendous impact on what we're shooting for decarb, what becomes the 2050 goal, basically. So we have 100 substations right now to make this real simple. And we've got a lot of experience with non-wire solutions, a lot of experience with energy efficiency, some experience with microgrids. We're going to be very creative about doing that, but if our peak load did triple, that would imply 200 substations in the next 30 years. We all know that that's not going to happen. I'm not here to suggest that. But even some fraction of that requires a tremendous amount of upfront planning because the typical substation takes 2 or 3 years to build. So you can't just wake up one day and decide that your load is double and you got to meet that. And again, I think everybody knows that. So again, very excited about the opportunity. I think it's exactly the right thing that NYSERDA is doing by laying out this roadmap with everybody involved. Looking forward to seeing what we come up as a plan, and then we'll work accordingly to make it happen. Thank you.
Thanks, Damien. What I've got there is that hybrid can have a positive effect in that it helps us avoid tripling the electric peak. We've got some pretty critical issues to deal with depending on the choices made in terms of including the impact of how much time is actually available during the course of the year to schedule outages, with cost implications there, and how far down that electrification path we go, impacts the types of capital investments you need to make on the volume in dollars of capital investments on the electric system.
Exactly. Scott, I apologize. Can I just make one more quick point too? Currently, I forget exactly what the numbers, but New York City reliability law has over 80% of the generation in city. So another dynamic that's going to be taking place is you retire those fossil plants that are in city, not all of which are peakers. Some of them are combined cycle and some of them are just good old-fashioned Rankines that dial up and dial down all day. Even the goal of the 3,000 megawatts of 4-hour batteries is not going to be nearly enough. So again, we see, we're excited about its opportunity for Con Edison. We see batteries as being part of our solution as well as our customers and other players in the market. And then again, it just makes that need for T&D even more important, be it taking it from 9,000 megawatts of offshore wind or thousands and thousands of megawatts of upstate wind and solar, and also incorporating the batteries.
Great. Before we move on, let me just check if it's not clear. Can folks in Albany hear us?
Yep, we can hear you just fine.
All right. And is anyone online that can hear this question? Somebody unmute and check in with me if you can. Okay. I think what I'm going to suggest we do, and I'm looking nice sort of people to wave your head vigorously, no if you don't want me to. I think we have a very short-term technology thing going on, and we're supposed to take a break in 20 minutes. So I'm going to suggest we take the break now, and then try to get this resolved, and then we'll finish this conversation and then roll right into the second question. So what I'm going to suggest is we start back up. Is that okay with my server folks before I do it? Okay. How about we start back up at 5 of, so 2:55 we'll reconvene, and once we have the ability to tell people online, we'll tell them that, and folks in Albany, we'll see you at 5 of. Thanks all for your patience. Sorry for that.
Can I just ask a quick technical question? You were talking about 13 gigawatt summer peak. The 2019 goal book for 2018 says you guys are only at 10.89 gigawatts, and it shows you...
That might be just New York City.
Hello, all. So we believe we figured out the meeting question, and so for everyone that is on the webinar, you should probably now make sure you are muted, because we're going to hear you all, and we are going to, we jumped into our break, not knowing while we solve this. We're going to reconvene at 2:55 and pick the conversation back up. Thank you.
Yeah, they're back. Now, I'm gonna try and get back into the VM. Try and get back into. Really? Getting audio through my laptop.
Okay, well, we'll have people. So you guys,
Can you hear me?
Yes.
All right, you can hear me.
Hi, I think folks on the phone or dialing in can't hear anything anymore. I don't know if there's a mute button or if it's just the system's issue again.
Yeah, I confirm nobody he can hear.
Hello, this is Albany. Can you? Oh, where do we have to mute? Everybody on the phone has been unable to hear you. We need to make sure the communications are working.
Oh.
No one on the phones can hear you.
Is there feedback?
So Albany can hear New York through the phone. Can people on the phone hear New York?
Can you hear us? Here we are. Can you hear us? This is New York.
We can hear that now on the phone.
Again now.
All right, we're set.
All right. So it didn't take us till 3:20, so I suggest we reconvene. So we'll get going here. Thank you all for your patience. I'm sorry that occurred. It's a technology thing, nothing else. Seems like we have it for now. So you may or may not have been able to hear what we decided. We stopped the last conversation after getting what we could from folks. And we're now going to move into the discussion about future-proofing what near-term investments are needed to support building electrification and grid integration. We've got plenty of time for that. We've got more than an hour for this conversation. What we're really looking for is to get you all to contribute your best ideas, goals, research that can push utilities, government, building owners to move out of business as usual and reach carbon neutrality by 2050. That's the notion here. So we're wanting you to now really think big and be thinking about that not only now, but 2035, 2030, 2025. Be thinking of, put yourself out beyond that planning horizon where we ended our last conversation. And then, be thinking in a wide way. We've got a bunch of questions that we, could you pull those slides up for a minute here so we can show people these questions just to help prompt you all and get you back into the discussion. So it's things of like what are risks and issues of widespread grid interactive building adoption capacity, grid utilization rate, peak demand. We have new grid network and market capabilities that we'll need to support the electrification of the building stock, how building resiliency efforts and measures can have positive impacts on building grid interactivity while simultaneously addressing system peak load constraints and grid utilization rates. We go to the next page. The current state of technology for grid interactive buildings and critical technologies that we need in these coming time horizons, how distributed energy resources, on-site renewables, and electric and thermal storage, we didn't forget Kevin, can mitigate grid and network peaks and improve the grid utilization rate. Are there working models of these systems in the U.S. or Europe? What would motivate building owners to scale and implement grid interactive buildings? Is financial value enough to motivate a building owner? What changes need to happen to maximize the financial value of adopting grid interactive capability in the buildings? And what are the best models that exist? What are the gaps with our current grid and how do we make this work in New York State? You don't have to answer any of those per se. They're all to get you thinking along the lines of the types of responses that we're hoping we get from you as we think about this broad question. So let me open the floor. And because you've been knocked out of the conversation for a while, let me just check and see if there's anybody in Albany that is looking to join the conversation.
The line's open if anyone wants to go.
I would say as a developer, one thing to consider for the future is not to penalize building owners of larger scale buildings if they want to have just a 1 meter for a whole building. In that case, where they would get demand charges, for peak use, like let's say on a winter day like today, after dark, if they have solar, renewables, and all those type of things. That's about the main thing. Is we should think of a plan so we're not penalizing building developers that want to do a project large scale where they want to try and make it zero energy, but they will have peak demand charges to consider.
Great, thank you. So I think, what I heard there was making sure that we don't end up with penalties for trying to do the right thing.
Yes, not penalizing the developers for that. Yep.
Perfect. Anyone else in Albany?
Sure. I just have a couple of clarifying questions. This is Katie O'Hare from the Utility Intervention Unit at Department of State. I just wanted to understand the scope of the roadmap because I saw on an earlier slide that it was going to include a business case, and I just wanted to understand, is that business case going to cover both the individual building owner, potential tenants, and then ratepayers and other people that might be funding additional initiatives as part of this proposal?
Do I have a NYSERDA resource that can answer that question?
So can you ask the question again, and then I'll answer it?
Sure. Just a clarifying question to understand the scope of the benefit cost analysis that's going to be included in the roadmap. So will that include a look at potential costs to ratepayers if there needs to be additional utility investments, as well as potential costs for the funding of energy efficiency and others?
So in the section under value proposition, it looks at the value proposition. So I'll just go across the different groups that are included. So the owner, occupant of the building, tenants of a building, the developers, investors in the building, and then it will look at societal benefits beyond the actual building itself as well.
Okay.
Does that answer your question?
I think I'll have to take it back and just get more information, talking to our technical people to see if there's more that we need to consider. It just seems to me like we're talking about the potential for winter peaking and then looking at energy efficiency in other areas to mitigate that risk. Right. So just understanding if there's going to be a ratepayer impact or a consumer impact on that. Right.
So there will be, and they definitely need to be looked at. And in terms of two of our target sectors, we're looking at multifamily housing, including the LMI space, and we're looking at single-family housing in this iteration of the roadmap. So those will be the areas where there'll be of particular importance. Thank you.
Anyone else in Albany?
Yes. I think in the near term, I think sort of addressing sort of locational sort of hotspots as either buildings individually need to upgrade their connections, or you get more sort of the like LSRV locational system relief zones that need to be upgraded or potentially expanded into non-wire alternative areas, and how to, whether those should be ratepayer subsidized as part of a, sort of statewide policy to not, penalize the existing building owner or building developer for needing a upgraded connection to electrify, and be able to sort of socialize that cost.
Great, so addressing those locational hotspots in a way that doesn't penalize the building owner and helps to socialize costs, I think what I got from you.
Yeah.
Great. I'm going to come back here to New York City for a couple of minutes. Before I do that, I'm going to encourage, if there's anyone online, since we had this break for a bit, if you want to enter the discussion, please do ping us in the system you've been using online, and then I'll know that you're looking to get into the conversation. So just an invitation for you to rejoin us that way, and thank you so much for tolerating our challenges. So while that happens, let me come back to New York City and see if anyone would like to come into the conversation.
Mark Luaga, Stephen Winter Associates. On the subject of future-proofing, one thing I want to call out is just behavior and heat pumps in particular, how it's not just the outdoor temperature, but it's the indoor temperature. And New York City, on the residential side, where tenants don't pay for heat, 80-degree apartments are kind of the norm. If we take those buildings and put heat pumps in them, the bills will skyrocket, and it doesn't matter who pays it. So even if we can't electrify those buildings in the next 10 years, I think it's really important to move the market towards kind of, paying for the energy they use on the tenant side. And I think that behavior stickiness will have a translation to the heat pumps when they eventually get in those spaces. And I think it's really important to basically have tenants that know how to use heat before you put in the sort of more of a Cadillac of a system that they're on the hook for paying for. So just putting that out there. Also, I think it's really important to be thinking of equity and cooling as a kind of just the, newest equity issue as global warming comes into play. And, as soon as the heat wave goes to New York and a few seniors die in a NYSERDA project or wherever it is, it's going to be front page news. The questions are not going to be what does it cost to do this? And I think there's an opportunity to use the provision of cooling and affordable housing to, do heat pumps at that time and the new electrical infrastructure it requires, or there's an opportunity to dismiss that. New York City Public Schools are obviously just added, cooling over a 5-year period. They're in the middle of that. That started, a year ago, and I think that was kind of probably too early in the game that they're not really taking advantage of that timing-wise as a heating electrification opportunity, and just calling out that would require planning to take advantage of that in the future.
So 2 keys there I heard,
with all steam heated buildings, yeah.
That's on a cold day.
So 2 things there I heard. Make sure that there's a way to get the tenant market ready for a transition to electrification, that we begin to make sure that they understand the energy they use and pay for it even in the short term before heat pumps. And then the second is to deal with equity cooling issue by advancing heat pumps before we have a problem rather than after. So I think what I caught from that. So, who else?
Hi, this is Charlie Marino from ATS Engineering. Related to the grid interactive building topic, my understanding, which, there's only a few white papers really on it right now, published in the past year or so, and the essential piece of that is open ADR, automated demand response. And although that has been successful on the West Coast for a couple of years now, this particular region hasn't really been focusing on that particular topic. So I think we have a long way to go in terms of grid interactive buildings and just understanding what the specific foundation is going to be, whether or not building owners are going to use demand response consultants like we do today, or if we're going to see some type of new relationship develop between the utility directly to a building, or I don't know if the NYSERDA somehow is a little more specifically connected to the building and simultaneously parallel to the utility. So a lot of variations there, I think that need to be thought about.
Right, and so just in case everybody doesn't know open ADR, please correct me, my take on open ADR is the ability to get the grid interoperability questions, make sure that all the devices can talk in a common language and be kind of funneled through. And you're right, California is now, I think in January, this coming January, it's required that all devices and communicate with open ADR as a matter of state policy. So is that fair?
Yep.
Yeah. Just so that I make sure we get that right.
Yeah, there's an issue here, particularly within the residential community with metering, because if we want people to be able to use the meter data to respond in any way to in real time, they need to be able to get real time data. However, we have a number of utilities like Con Ed who refuse to provide so far capabilities which have been declared by the Public Service Commission to be minimum capabilities for an AMI system, and that is home area network access to the data, which would allow you to have real-time access to the metered information about whole house load. Without that information, it is very difficult to do anything in response to, say, peaks in either KW or KWH. Now, there are suggestions that, they'll put information on your electric bill, which will come, at the end of the month, or that you might be able to use Green Button Connect, which will be 1 or more hours delayed, and it has a variety of interesting interconnection requirements and things like that. But at the moment, we're going to have to find a way to convince our utilities to actually allow us access to the real-time information in machine-readable format, okay, within our network, so that we can hook up things like, if there was a heat pump, for instance, that wanted to read whole house loads, so we could adjust its behavior in response to it. Or if you had a computerized system that was essentially doing some sort of load management within your residence, you have to have access to that data. The alternative is that we'll just be forcing people to put on additional meters course, then those meters won't agree with the utility meter, we'll have all kinds of issues and such. But we need to impress upon utilities that we actually do expect not just people to go in every once in a while, look at the cool data that's coming from the meter and maybe be informed, but we're expecting a future where we expect technology to be able to be managing this load intelligently, and we can't do that without systems which conform to the PSC declared minimum requirements. These minimum requirements have been in place for over 10 years now, which require that we have whole area network access to the output from AMI meters that they're being installed.
So from an investment perspective, I think what I'm hearing that, to try to reframe it into an investment, is I presume that on the utility side, there's a question of barriers and investment.
The costs have already been incurred. All of the meters actually have a chip in them, which allow them to be, which allow home area network access. It's just the decisions are made not to turn them on.
So then it's more of a policy regulatory question.
Yeah.
Great. I'm just trying to make sure I capture it correctly. Amy, it looks like you want to come in. I'm going to come on in, and I'm going to encourage us not to end up with a debate, but if you have a different point of view, by all means, let's hear it. Yeah. I'm not trying to tell you no, I don't want to have you two kind of firing back at each other.
No problem. I was just going to say, we're rolling out our AMI. We're very excited about all the things it can do, but right at the moment, it's not even completely rolled out to everybody. So, no, it's a matter of kind of getting it to do what it has to do first, getting it to everybody. We're certainly excited about all the things we can do with this.
Great, thanks. So AMI is on the way. What I heard there.
And hopefully home area access to AMI data is on its way very soon.
Let me try to make sure I'm getting everybody. Is there anyone online that you know? No? Okay, anyone in Albany want to get back in?
This is Joe at Pace Energy and Climate Center, and as for the questions on AMI, I was saying that there is limitations on the sort of access and usability, both on the installed AMI and the AMI that has not been installed yet or is not currently being planned to roll out within the state in many areas. So there needs to be some kind of some kind of alternative to enable interactive buildings in places where there isn't or aren't going to be AMI meters, and there may need to be other broader signaling that is maybe weekly or day ahead or not hour by hour that people can actually respond to without having integrated meters and management systems in the short term, because I think that's going to be, especially for single-family buildings and many existing, commercial and multifamily buildings, they're not going to get, these advanced smart controls. That's not going to happen in the short term. So there needs to be some kind of, second-order optimal pricing and optimizing system that they can actually respond to.
Great, thank you. And so what I heard there is if and where we're not going to have AMI, then other mechanisms to be able to manage these control devices and participate in these systems. And only because I used to run a company in this space, these alternate mechanisms to do the same thing already exist. A lot depends on what your market rules are and whether or not in the market and or the assurance of what you promised to accomplish, how the rules all address that. So I can just, for what it's worth, I can offer that.
Yes, and that's exactly what I'm talking about. Thank you.
Anyone else?
Yeah, this is Aaron Breidenbach with Consumer Power Advocates, but also formerly with Enernoc, which is the largest demand response company in the universe, I think, or known universe at any rate. And then also used to work at the New York Independent System Operator on the same kinds of issues. And I don't think any of this is really news to NYSERDA or the Public Service Commission, but since we're talking about it, I'll just make the point, which is, if we're talking about grid interactive, which is, I guess, the title of this thing, grid interactive buildings, then, the idea, I think of that, and I think of, how do these buildings and their ability to use or not use energy sync up with the market opportunities that are going to be available at the grid level. And I sort of view that as two levels, which is sort of the wholesale level. And so we're talking about the New York ISO wholesale market opportunities, whether that's energy capacity or ancillary services. And then at the utility level, where they have the, each of the utilities has its own distribution load management programs, many, which for the most part mirror the ones that the NYSO has at the wholesale level, just at the retail level, although there are differences there. And I think people, generally speaking, know what needs to be done, that we need to open those markets up to, both at the utility and at the NYSO level, to loads, and we need to do it on a basis that is, not only, on a basis that it not only protects reliability, which I think that, the NYSO is perhaps in some ways overly focused on, to the, to the detriment of the other aspect, which is it has to be something that people can actually work with. And, what we have in place, and it also, I think, taking a nod to the experience that we've had with the demand response programs, which at both the NYSO level and at the increasingly at the utility level have been fairly successful, growing apace, I think, at the utility level. A lot of the utilities are fairly new at this stuff. Just a few years experience with those programs, but they are growing. The key has always been to facilitate the participation of market intermediaries, so demand response providers or aggregators or whatever. And so we need to have rules in place that one, provide fair value for the services offered, and do so, using program rules that people can actually live with. And, I think the problem right now, and I probably spent already too much time getting into it than I need to, because I think, NYSERDA at least has been making this case at the NYSO, is that we've got rule sets that are going into place that, as I was telling somebody earlier today, that, they very much risk building it and no one comes, because it's going to be so technically complex for people to participate. Just because a 600 megawatt power plant provides 6-second telemetry from its site to the New York ISO does not necessarily mean that, an aggregated group of residential facilities needs to provide 6-second telemetry data, from every one of those sites, aggregated up through, a containment service provider and then to the NYSO. So, and then, another thing is you've got to be able to stack all of the different value components that you can together. So there will be value that can be had at the retail level, there'll be value that can be had at the wholesale level, and a resource that can provide both without sort of being double counted needs to be able to do that. And yet we have, at least at this point, ambiguity as to whether or not what is referred to as dual participation, whether the same resources are going to be able to participate and provide services at the utility level and at the wholesale level, and even then at the behind the meter level. Because I think the bottom line is most of these buildings that are going to be doing this stuff, and this is the case for the guys that I represent, is if they install storage on site, it is not primarily going to be so that they can provide ancillary services to the NYSO. It will be because they want to provide services to themselves to basically do peak shaving, for example. And if you tell them that they are not going to be able to provide peak shaving and wholesale ancillary services, or that in order to do it, they're going to have to jump through 6,000 hoops, they're just going to end up not doing it at the wholesale level, which means that that value stream is not going to be available, which means either they're not going to build the system as big as they could, and that those resources aren't going to be available, or they will build it, but somebody is going to have to pay them more to do it. And we're already going to be, you know, this is going to be a phenomenally expensive undertaking as it is. And to the extent that there's value that can be had, like legitimate non-subsidized value from the wholesale level, we need to be able to get at that. And, you know, what we have right now, what we're seeing being developed is a bunch of rules where everybody wants to make sure that, you know, nothing bad happens on their little section of the watch, and everybody's being conservative in that way, and we end up with over-conservatism to the point where people are not going to be building systems to an optimal size. And so, I don't know, that's a sort of fairly long-winded way of saying that, you know, we need to coordinate better, we need to maximize value streams. The PSC is working on it in their value of distributed energy resources case. You know, the NYSO has projects that are going on. So the work is being done out there. It's not like, you know, anybody has dropped the ball. It's more a question of, you know, people doing things in a way that are collectively overly conservative, and that over-conservatism is going to deny the resources access to revenues that would allow them to, you know, build out a bigger base of resources than they would otherwise. So.
Right. So I think, you know, what I hear there is if the goal is to really have you create these grid interactive buildings, we've got to make sure we get the rules right in a way that people will want to be able to do that. I'm just curious, since we have your expertise here, obviously you know more than the NYSO and New York utilities game. Is there a place in the United States or elsewhere that you think is doing the best at this? Who's getting close to right?
We are. I'm serious. Like, I mean, this is completely cutting edge stuff. There really is no place. And I was involved in looking at this stuff overseas as well. And Europe and Asia certainly don't have anything on the United States when it comes to this kind of stuff. Maybe, you know, maybe aspects of, you know, offshore wind. Yeah, you have more experience of that in Europe. But in terms of this sort of building level, demand response, demand management type, like, you know, we're about as good as it gets, and that may be damning with faint praise. So there's not, as far as I'm aware, there's not, I mean, there may be individual sort of test cases that you could look at, but in terms of, oh, let's do it like, I don't know, I'm just pointing at Yugoslavia, because nobody's going to choose Yugoslavia. You know, do it like Yugoslavia is doing it. Well, you know, there is no Yugoslavia out there that's doing this really well. It's all brand new stuff. We're all finding our way through the process.
Great. I'm going to take us to a question from online, but I'll just point that one area that we could monitor in the coming years is all the various ISO's response to how they deal with FERC 841, which is, of course, in the middle of the space. Might be something to just keep our eye on. But I know online, I think we have Alexi Miller, so if you'd unmute yourself and join the conversation, Alexi.
Hi, can you hear me?
Sure can, thankfully. Thanks for holding on with us.
Fantastic. Hi, thanks for giving me a moment here. This is Alexi Miller with New Buildings Institute. I'm leading the Grid Optimal Buildings Initiative, and I'm involved in a couple of other efforts around building grid integration. So my question is this: a key strategy for enabling large-scale electrification, like we're talking about here, I think has to do with enhancing energy flexibility or demand flexibility in buildings. And what I mean by that could be a couple different strategies, you know, lots of different ways to skin a cat here. Could be thermal storage, battery storage, controls optimization on the HVAC system, scheduling of one system or another, different ways to get there. And we've been doing some work to develop metrics that describe these capabilities and what their benefits might be at the whole building level, right? The level of the meter. My question is, can you describe any work done to date with this team to get an idea of the potential scale for building energy flexibility to play a role in solving some of these electrification challenges compared with the scale, for example, of fundamental efficiency like core and shell, or grid scale storage like batteries, be above the level of the meter, substation and on up. Just trying to get an idea of how big a potential you think we have in buildings to do flexibility versus trying to get there another way. Thanks.
So to a NYSERDA resource, are we aware of an analysis that's been done on that, or is one of our current vendors, contractors on this actually looking at that question, or is there, anybody have a response to that?
Yeah, this is Matt. So at NYSERDA, we are looking at building grid interactivity. I don't know that we'll necessarily include a metric in the roadmap itself or not. I think we're going to evaluate all the different options and try to present what that information is. I don't know that will come to the form of a conclusion at the end of it, though.
Related to this. Yeah, I would just add that the way that we're organized, we have a team under Carl Moss that is working on the grid side of this issue for NYSERDA. It's not a specific charge of the buildings roadmap team.
I have a question that's related to all this. A couple of years back, I remember talking with people at Orange and Rockland Utility, and they were working on a pilot program that was working on a grid interactive systems with homes and businesses, where they would be using smart meters to turn on and off local appliances at the optimal times of day to save the customers on utility costs. Does anybody at all anywhere know about this program, if it ever came to fruition and has any results? Because this is exactly what everybody's talking about.
Is there a resource that knows how that pilot went?
Yeah, all I know is that I was talking to Orange and Rockland when they were just starting the pilot program. I knew several people, they signed up. There are Bluetooth interactive appliances in the home that were going to be turned on by the meters when the rates went up and down. They were going to do it at a lower rate. You have washers, everybody talking about the dishwasher, the clothes washer, the hot water heater, and then there were plans where they were going to amp up the AC systems in the homes before the peak hour came when everybody came home, so it wouldn't come up when all these ideas that we're talking about. They were doing in that program. If anybody has any idea if Orange and Rockland ever did it.
I think that could be one takeaway that we'll capture here, is that we'll check in with ORU on the results of that pilot. And then secondly, I think I heard from Alexei, based on the answer of where we are, I think, Alexei, I heard you suggesting that getting some sort of market potential characterization on flexibility, it could be an investment in the future to really understand what the potential of grid interactive buildings could be moving forward. Is that a fair characterization of what I heard from you, Alexei?
Yeah, I suppose it was a bit of a mix of a statement and a question. So the statement side of that might be that I think there is significant potential for flexibility in buildings to help solve some of these problems. But I think I agree that it might be useful to dig a little deeper and figure out what's the most cost-effective and impactful blend of energy flexibility and other resources that can get us to the same place.
And for everybody who knows, what I'm trying to spin these back to you as much as I can, where it feels possible to me, is what can an investment look like, either for a utility, for NYSERDA, for somebody else, to help solve the current barriers so we can move forward. So to the extent you have that, you can put it that way yourself. If not, just put it out there and I'll try to flip it for you. Let's go back to New York City. Who'd like in? Come on.
Sure. If the question is how do we get to what investments need to be made to get to long-term significant electrification, in a big way, I'd say in the next 5 years we need to do, medium scale implementation of projects. So there's a big difference in the R&D versus deployment. I think we need to do a lot more deployment. And, you know, it makes a big difference to do a couple hundred sites as opposed to one or two on a kind of one-off basis in terms of what we learn training contractors and kind of real world kind of scale stuff. So I think we need to do a lot of that and learn from that in the next 5 years to be in a much better place for, you know, 10, 15 years from now. And I think there's an acute need to do that in the sectors like downstate larger buildings where there's less kind of proven kind of technologies and retrofits, but it can't be a one-off building sort of thing. We need a lot more experience pretty quickly.
I think what I'm gathering out, teasing out of that is, so we want to get kind of medium scale in. The key I heard there was there are some additional costs there to make sure we learn and we capture the information and we learn how to do this well that are important for us to figure out how to bring the investment to the table to make sure we can get to that level of learning. Is that right?
Yes, and what I'd add is if we only have 30 years, there's an additional expense to waiting, you know, learning those lessons in 10 years as opposed to 5. So,
yeah, I'm definitely here to move on it. Good, thank you. Who else? Come on in.
Thanks. Regarding unlocking true potential for commercial office buildings to look at exactly what type of battery energy storage system they can get on site today. Right now, for a few studies that are underway, they're focusing on how to maximize utility demand savings, right? But if we're talking about a grid interactive building, that's a different ballgame in terms of what the financials would look like for sizing, maximizing the size of your battery system for potential on the grid rather than just for the individual building's utility rate. So it'd be interesting to see in the short term, you know, what some of the thoughts around, I guess, from NYSERDA standpoint, I guess, in terms of things that would go beyond necessarily Con Edison. So to think about additional incentives that could be put in place for someone to maximize the true battery energy storage system capacity for their site. Of course, we're thinking about the future, so I'm just kind of jumping over the barriers of today. But I think that's an important piece, and in order to pull on capital projects in the next 5 years, that really has to be thought of right now rather than looked at in a decade from now when we might have missed the boat on some storage projects.
We need to really, you know, drive some implementation of some new ideas. You mentioned maximizing battery storage impacts as one example of that, to really learn and drive some market early so that we can then ramp up after. Is that right?
Yep.
Perfect. All right, just to try to rewarm the room, we've still got plenty of time, and I'm not going to take it all from you if you all run out of gas here. I'm just curious, any ideas from around the United States or Europe, any best practices that you've seen that are worth us investigating, things that other places have invested in that have made a difference in towards strategic electrification of grid interactive buildings? You know, not every place calls them grid interactive buildings, but you know, the notion of these assets being part of the grid now. And go wherever you want. You don't have to follow that question. I'm just trying to have you rethink. Come on.
Yeah, well, there's one really great example in that of something which is very important here, and that is planning. I don't know if you guys are aware of the fact Netherlands is in the process of a very large electrification process at the moment. They have the odd distinction of being one of Europe's largest providers of natural gas. They unfortunately discovered that pumping natural gas from underneath your country can cause your country to sink. So they decided to stop mining natural gas and, in fact, to convert the country off of gas and to non-gas heating, primarily electric. So what they've done is they've cut the country up into little neighborhoods, and they're scheduling. They're basically telling people your area is going to be converted to the new technologies, say in 2025 in November, and the guy in some other area, he's getting converted so many months later and his neighborhood is going to be converted. And essentially, they're giving people some certainty as to when they need to make shifts, and then bringing in a whole lot of focused resources to those areas in logical sequences, as opposed to doing individual houses at a time. They're essentially doing clusters of houses and buildings. And that's something that we found very important here in New York City when we did the oil and gas conversions necessary to go from number 64 to Volta at the time of cleaner fuels, is that by building up clusters and by working with essentially converting neighborhoods and communities as opposed to one building at a time, we were able to be much more efficient and able to produce a much better experience for the homeowners. We find that as well even with geothermal. You guys probably know that one of the biggest costs in installing geothermal is the cost of drilling. Well, it turns out most of the cost of drilling is actually the cost of not drilling. It's the cost of driving trucks around and moving equipment and things. If we drill 2 holes at once, instead of drilling just 1 hole, if we drill 3 or 4 or 5 holes, like we basically do a block or a street or a neighborhood, we dramatically reduce the cost of drilling. So I think we need to think more in terms of converting communities and neighborhoods instead of converting buildings, which is where our focus is now, and plan ahead. The other thing I'd like to suggest is an important issue, and maybe it's out of scope, but I think it's one that should be mentioned, and that is that there are participant costs involved here. People have to pay for this stuff, and we need to think about the financing, and most importantly, I think we have to recognize that we're talking about very large capital costs, that a very large percentage of our state's homeowners and even building owners are not going to be able to afford. They don't have the available credit at the moment. We need to be building mechanisms for third-party ownership. Third-party ownership was very important in getting the solar industry off the ground. I don't think we have the solar industry we have today if we haven't had third-party ownership. They may be moving away from that model now that their costs have come down so far, but we desperately need third-party ownership, effective third-party ownership in the thermal side of in the building electrification space. I think we can have lots of very fine plans and ideas, but if we can't figure out how to actually get somebody to put the cash on the barrelhead to buy the equipment, it just doesn't matter. And a lot of this state simply can't afford to do the right thing.
Great, thanks. So Netherlands as a potential example with scheduling areas. Actually, it's interesting. I mean, in the old model, you'd never think that was possible, but if we're really thinking of buildings now as part of the grid interactive buildings, scheduling them like you would any other investment begins to make a lot of sense potentially. So that's an interesting thought. And then
substations, everything,
all the systems. And then this notion of to deal with the large costs, how do you deal with third-party ownership as a service models, all those mechanisms to try to get the investment made for people that otherwise aren't going to be able to make the investment. Who else would like to hop in? I haven't checked in with Albany in a while. How's Albany doing?
This isn't a, I guess a positive lesson learned, but a, still a good cautionary one is that making sure that, if there are programs for grid interactive buildings or, any kind of policy set up that way to, make sure it isn't like current demand response where sort of, the easiest way to respond to demand is turn on a fossil fuel generator. So, I know this is all, in the context of, carbon neutral buildings, but, making, just keep in mind to make that explicitly clear in any kind of program or metric for grid interactivity is making sure that it's not relying on fossil heating or fossil electric generation on site.
I get that, thank you. Do we think that there's sufficient standards, code, regulations, law to make that clear today, or is that something that needs to be accomplished to make that vision happen?
And that's something that needs to be accomplished under the context of current demand response programs.
Great, thank you. So we'll capture it that way. Thank you. Anyone else in Albany?
Just a clarifying question. Is the roadmap, how's the roadmap considering reliability when it talks about different incentives and parts throughout the state?
Are you talking, so I just have a, are you talking grid reliability? Yeah. So the grid reliability is an issue that would be identified by the roadmap, but the roadmap would not be the vehicle for solving grid reliability. So we are, the roadmap is the building side of the equation, not the grid side of the equation. I mean, we're having these meetings because we need to make appropriate assumptions about the grid in the future. We need to describe what qualities of the grid are essential to decarbonizing buildings. We also, as I had mentioned at the beginning of the session, we need to find additional value streams to get this level of investment made in decarbonizing buildings that it would take to actually achieve the task. And the grid, beyond the grid meeting the minimum requirements, the grid is a potential source for an added value proposition. So.
The one thing I'd add, with the response, Patrick, in our definition of grid modernization, we actually, that issue is actually addressed. So the intentionality here with grid modernization is improved reliability for everyday operations, and then resilience is very related to reliability, so greater resilience to hazards of all types. As Patrick said, that will be done somewhere else, but I just wanted to point out that in the guiding definition around grid modernization, the notionality is that that's going to improve in answer to the question. Anyone else in Albany? Okay. Let me point you to another question. Again, go wherever you want. I'm just trying to keep the conversation going. Since we were just, it's funny, I just come to this question about resiliency when we went to reliability. So thoughts about how building resiliency efforts and measures can have positive impacts on building grid interactivity while simultaneously addressing system peak load constraints and grid utilization rates. It begins to tie off a lot of pieces that you've been talking around and in parts of, but I'm kind of curious if that prompts any additional thoughts from people. Yeah, go ahead, Damien.
Damien Ciano, kind of said, yeah, no, sure, energy storage certainly comes to mind when you mention that, right? I mean, to the extent that you can add a battery to a building, it's a resilient asset when you need it for that, and it can also certainly help do demand response on a regular basis, right, as well as other things. Frequency control, if that ever becomes a part of the market, I'm sure it will become a part of the market.
Are there investments needed to help that move that along, any of that along, from your perspective?
I mean, from our perspective, we learned a lot with solar panels because they use inverter-based technology, which is very similar to batteries. So even though I know we're not going to be 100% on the same page with everybody in the room, we've streamlined our interconnection dramatically. At some point soon, we'll have hosting capacity maps for both EV and energy storage. That's certainly on the New York State roadmap already. Again, I know there won't be full agreement on it, but we think to some extent our standby rates do incent batteries and work for them. And obviously there's continuous and ongoing hearings to make those better and more responsive and think forward into the future. In addition, our non-wire solutions, we certainly love to see when we get a lot of batteries come into that, as well as energy efficiency, fuel cells, demand response, et cetera, and so on.
Others? John, online. I don't have your last name, but hop on in. You just pinged us on to join the conversation.
Hi there.
Hi there.
I wanted to mention, it's John Shabaka with Aztec Geothermal, that the AEC credit, which is essentially a carbon credit in Massachusetts, is requires that ground source heat pumps be sized to cover the peak load without any use of auxiliary, so that they don't end up having a big demand peak from a technology that can avoid that. So, and that's pretty much the way that we try to size all our systems, both in Massachusetts and in New York, is start to a sort of future size. So a lot of times a 5-ton system, we might put in a 6-ton so that it doesn't end up using auxiliary on that peak winter day. So that's just something we could consider, that in utility, NYSERDA or utility programs for heat pumps, that we try to get systems that are sized to not go into, say, an auxiliary electric. The other thing that we do with some frequency is we design, especially much older building stock, let's say like an old farmhouse that isn't well insulated, they want to switch to heat pump technology. And so sometimes what we'll do is we'll do a combination domestic hot water boiler, and then that'll be an auxiliary and backup system for the heat pump. So the heat pump, say, is sized at 5 tons. The house really needs 6 tons or more, but they haven't insulated it. And sometimes people can't afford to do a significant amount of energy efficiency, say, in terms of insulating an older building before they go to electrification. So there might be some hybrid opportunities there. I think battery storage, once we have rates that would incent people, especially in homes, to use some type of electric storage, because that also could be used as something that would pick up an auxiliary or backup load to avoid having that peak end up being pushed out onto the grid. And programs could be developed that help incent that. But again, until we have rate structures that support it, I think it's difficult to really incent people to go in that direction. The last comment that I had around that, or I'll go back to the covering the peak. Variable speed technology, especially for residences in a lot of New York State, have a much higher heating load than a cooling load. And what variable speed technology allows us to do is size for that winter peak, but not be oversized for air conditioning. So we don't end up having an air conditioning system that that doesn't have enough runtime to dehumidify properly, or short cycles. Even 2-stage systems, when sized to cover the peak, sometimes are oversized even in their first stage, which is 66% of its rated capacity. They're oversized for air conditioning. The last thing I want to say is that I do think too, as in certain incentive programs, say a rebate program, there might be some kind of kicker incentive for remote monitoring and control and data logging, something that would encourage contractors and homeowners to install technology that would help us understand how these systems work more comprehensively, rather than feel like they have to put in a lot of extra money to give New York State and other places the information that they need to make these decisions.
Great, thanks, John. There's a good amount there, and I definitely heard a call for getting the rate structures in place that will enable some of these technology choices you were talking about. On your first point around sizing heat pumps, it strikes me that could either be tied off to when incentives are involved, or it could even just become a code and standard requirement. Yeah, and I think, and I heard that an investment from the R&D side would be in these early days, as we want to characterize the outputs, is to help to cover the cost of these monitoring devices and data sharing mechanisms, so that we can actually do this well by learning early. Others? Yeah, come on in.
Yeah, and to follow on what John said, and I don't want to sound like I'm disagreeing with anything he said, but just let me suggest some color here. It's often, what he said is often great. Yes, you got a 5-ton, it often makes sense to go 6 tons, so you can be handling the design day load without a problem. if you can go to variable speed, that's great. The problem is that both of those two things significantly increase the cost of the installed system. And that can mean, and that gets us into the situation which exists, I think, in many cases of, you know, are we allowing the perfect to be the enemy of the good? If we find that the variable speed, full load systems are, you know, are simply too expensive for people, what do we do? You know, there is an argument that says that even the benefits you get from a two-speed system are good enough that we should all be very pleased, and the homeowner should be very pleased as well, particularly if they're saving money. You know, they could have saved more money if they were able to invest more upfront with it as they saved money. We get a similar argument that comes on a more general level, and that is something that recently has been going on in the city. A lot of people have been arguing now before we do any electrification, we ought to make sure that the building has gone through deep decarbonization first. Because the most efficient building will be one that has not only gone through deep decarbonization, and by that I mean, you know, all the weatherization, insulation, et cetera, and that you can do, you know, convert it as close to passive house as you can get it, and then put the heat pumps in, and then you observe, oh yeah, the heat pumps will be a lot smaller, and you won't use as much. That'll get you the best result, okay? But it'll also take you a lot longer to get there, and it'll cost a lot more money. In Vancouver, the Metro Vancouver, Canada, Metro Vancouver Energy District or whatever, recently studied this issue. They have a 5-step decarbonization plan where you do like a little bit and a lot, et cetera, and by the time you're done, you got a really good building. And they compared the results of their step 5, okay, which was, you know, all the decarbonization stuff you could do with the impact of putting a heat pump in a step 1 building. So they put a heat pump in a traffic building. And they showed that if your goal is to reduce carbon emissions, the heat pump in a poorly insulated building had fewer emissions than a step 5 completely decarbonized building. So if your goal was to reduce carbon emissions, you would tell people, do the heat pump first, and then hopefully you'll have some savings and you'll be able to use those to fund the decarbonization later. You'll end up with a system which is a bit oversized and will not be as perfect as it could be, but you will have gotten us carbon reductions much sooner. You'll be able to take advantage of the latent decarbonization, which is essentially the passive decarbonization that happens because the grid is getting cleaner while you're continuing to use the equipment. And I think we need to be very careful about some of these decisions where, yes, the best heat pump system is going to be variable speed and probably, you know, a size large enough to handle the full load so you have no backup. No question, but that's expensive. And it could cause us problems. Yes, the best way to go do this is do complete decarbonization first, then size your heating and cooling systems when you're done. Yeah, that's the best. Unfortunately, it takes a long time, it's extremely expensive, and it means that a lot of people basically get exhausted before they finish the process. Often doing what's counterintuitive, doing what's not best, doing what's good enough, but not what's perfect will be the right thing to do. And I think we have to be very careful not to let the perfect be the enemy of the good.
Great, thanks. So in there, there's a few ways that I could spin through. Utilities under NYSERDA could pick up some of those sort of analytic choice pathways that you just laid out, all deep decarbonization, blending, and try to pick the right path in the state of New York from an economics perspective, making sure that all the right costs are included. That makes sense here in the state. On your first point, I wanted to ask you to clarify from your perspective, you noted that the cost is high for some of these solutions. And so my question for you, is that an inherently long-term answer, or is it because it's new technology and so it just simply needs market creation and transformation? Because the choice may be different depending on the status of the technology, right?
Actually, it's kind of like neither of those.
Okay, great. Which is it then? Okay. Because I assumed it must be one of those two. So I got it wrong.
No, the thing today is like, it's quote unquote cheap to do a new gas. At least it feels cheap if you're a consumer. Well, the reason it's cheap is because somebody else owns most of your gas system. It's owned by the utility. Even the pipes that come into your house, okay, they're covering all those costs. They don't cost you a dime unless you're far away. And in New York City, or Con Ed's territory anyway, the average length of a new service connection is 49 feet. Okay, so everybody gets their connections for free. They don't see those costs. If you go and you buy a heat pump, or you go and you buy solar panels on your roof, I mean, buy them yourself, not having somebody else own them. What you're doing is you're putting in the capital investment that in the normal electric or gas system would have been made by somebody else. So, when we talk about cost, we really ought to be talking about, think of it almost like the societal cost, okay? But also recognize that what we're doing with these new technologies is we're saying that the people who adopt them are going to be held responsible for the full upfront capital cost, where that has not traditionally been the case, okay? And that means that capital costs and the financing of capital costs ends up being much of the driving cost over the lifetime of the asset. This is why, by the way, I mentioned before, third-party ownership is so important, because most people can't afford to pay up front for the next 10 to 15 to 20 years of energy consumption, which is essentially what you're doing when you buy solar panels. You're paying up front for the next 20 years of electricity. Or with a heat pump, you're paying up front for the geothermal heat pump and it's CO4. You're basically paying up front for 3/4 of your energy consumption over the next, say, 20, 24 years of the device. So we need to make a distinction here between, there are two different words. Okay, there's like, what's expensive as opposed to, I don't know, maybe what's, the difficulty is with these new technologies, you end up with high upfront capital costs, but your lifetime cost of energy, okay, is going to be lower. So I can show you that the lifetime cost of energy, say for a geothermal system, a heat pump, an electric vehicle, or whatever, is going to be lower over that lifetime. But electric cars cost you a lot more upfront. Heat pumps cost you a lot more than a gas furnace upfront. Okay, the better heat pumps, geothermal heat pumps, cost you more than the air source heat pumps. Yet, essentially, the more you invest upfront, the better the return is over time. The lifetime costs are lower, even though the upfront capital is higher. So, and for some people who have money, people who have some wealth, they can look at that and they can say, "Oh, cool, man, this is an investment. I can do that. It makes sense to me." And that's why we have the wealthier people who are now converting to these technologies. Unfortunately, there are a whole lot of other people whose life is much more focused on cash flow, and they don't make investments. What they do is they try to minimize costs, and they can't handle the upfront capital expense. So that's when we talk about things being expensive. I don't mean over the lifetime. I mean upfront, and that's a problem we can focus on and we can address through a variety of mechanisms, so that the people who need most to save money can afford to save the money, instead of now the people who need least to save money are the ones who can most easily afford to do so.
So some investment in determining how to make the ability to make the choices we're talking about here from an economic perspective viable for people in all economic spectrum is something that could be addressed. To solve that barrier. Go here. Yep. Okay.
Yeah. Two responses to the feedback on Bob's comments. One, I couldn't agree more on the electrical, or the infrastructure nature of the comment. Some of these bigger buildings really kind of stops at the at the meter, but the new electrical risers have to be run up to the building. I mean, at the end of the day, that's what kills the economics, and that's rate basing or equivalent of that is what would be needed to electrify a lot of these bigger buildings. So just kind of putting that out there as an idea. On the notion of your Vancouver thing, I tried to Google the number of heating degree days in Vancouver. I don't know Celsius, so I don't know what they are. But I'm guessing it's about as mild as New York, and I think I'm out, as Spencer is aware, I've been a pretty huge proponent of looking closely with this new paradigm of traditional energy efficiency. I think there's some pretty cool parts in New York that no one would want to put in an air source heat pump without making some shell improvements. And so looking at things a little differently, and again, the bigger buildings, less skin-dominated downstate and the upstate buildings, but I sort of take your point. But I'm interested in like that Vancouver thing. And then a new idea to just throw out there in terms of a barrier is it's not even the first cost for these bigger buildings. It's the sort of ability to stage and implement kind of tenant space by tenant space, irrespective of first cost almost. So there's just a need, in my experience, on both the commercial and residential side for retrofit solutions that can be done tenant space by tenant space, as opposed to the whole building at once. And NYSERDA is well aware of that, but I just want to kind of put that out there.
So a few issues to invest in and resolve there are how do we actually get the electrical upgrades needed inside buildings? How do we deal with those economics? This kind of upstate, downstate divide on the blend between weatherization and heat pump technology and investment, and then this notion of retrofit solutions perhaps by being accomplished tenant space at a time. There's really not there.
That's a comment on
Please do.
At a point on Bob's comment, I think when we talk about finding ways to finance some of the upfront capital expenses, you could probably include building shell systems as well as the mechanical systems, because in a lot of cases those are really, it can be beneficial, but as you said, it's very sensitive people to do it up front. No reason not to think of those as one of the systems that we should be looking at.
Let me check in one last time with Albany to see if anybody else wants to enter this conversation.
Anybody? No, Albany's good.
Okay, anybody else here in the city? Hearing none, let me just offer my thanks for sticking with us here through our technology challenges. Much applause to the NYSERDA team for fixing it or getting it to work somehow. So thank you all. That was a lot of running around like crazy. Thanks to our speakers that teed us up for this conversation. We had a whole host of really good conversation here, I think, around what we've got to, well, what the technical challenges are earlier in the afternoon that we've got to overcome, and then here this last hour or so, what some of the investment potential opportunities are that could help us overcome those technical challenges. So all this then gets taken up and will become part of this process. But thank you all for kind of sticking with us through this. Really appreciate it. And you all actually did manage to keep your energy pretty high, so I really appreciate that. And with that, I think I'm sending this back over to Patrick in Albany for the final closing.
Okay. Thank you, Scott. And thanks to all of you for participating this afternoon. Just a couple of things to mention. If you're interested in participating in the session on steam plants and localized grids, that's coming up in January, so just reach out and let us know. Remember that we will be publishing a draft for stakeholder comment approximately the 2nd of April. And then we'll begin an open stakeholder process where you can comment on the entire roadmap. For things that you've suggested to us that are out of scope, we'll be passing that along to our counterparts who are working on this. We did have a meeting with DPS prior to this session. We will be having follow-up meetings with DPS to relay the feedback that we're getting. So I would thank you all again and look forward to a draft coming out in April. Thanks.